Hi everyone, so let's start our new topic now, which is time domain analysis of a transmission line. This becomes very important because less question has been asked on this particular topic. Okay, in previous gate examination, you would see only 5 to 6 questions have been asked. So if some topic which has been less asked, that also become important because there is high chances that in upcoming examination questions will be framed from this particular topic. So this is very important for you. You will get less PYQs, but we will solve a lot of problem. Okay, so time domain analysis we need to do. Like we need to do the analysis of transmission line when the switch is just getting closed or it is closed for a longer time and we need to see it at the steady state. Okay, so two kind of analysis we need to do. So first we are going to do the analysis when the switch is just getting closed. So a brief intro I have already given. In transmission line, what kind of waves are there? One will be the incident wave, right? Then there would be reflected wave. So first one incident wave would be there, then from ZL one wave will be reflected back and will be coming towards the source side. Now there is ZG, so because of that there will be another reflected wave, then another wave will be coming. So in that manner one wave will be going, it will be reflected by ZL, then it will go in this manner. Now here it will be reflected by ZG, then it will go in this manner. Now it will be reflected by ZL again it will go, again it will go. In that manner it will keep on going. But just as you close the switch, at that time which wave you would be having? Just as you close the switch. So there will be any reflected wave? No. Just as I close the switch, I will have only V0 plus, right? Then it will go to load, this V0 plus will go to load and it will be reflected back. Then it will come to ZG, it will be again reflected back. Then it will come to ZL, again it will be reflected back. But just as you close the switch, I am talking about at t equals to 0 plus. At t equals to 0 plus, you will only have V0 plus. Do you agree to this point? Yes, you agree, right? Now V0 plus, what V0 plus sees? V0 plus sees Z in or Z0. In the first lecture we discussed it. What V0 plus sees? Along with that V0, certainly I0 plus will also be there. But we only analyze with respect to voltage. So just as I close the switch, from Vs voltage source, we will have a voltage wave, that is V0 plus, and we will have a current wave, that is I0 plus. So what V0 plus and I0 plus will see? Z in or Z0. In the first lecture, I told you about this. It will see Z node. Why is that so? Because there is no reflected wave. What is Z in? Z in is Vy by Iy. And in Vy you will have incident wave as well, e to the power gamma y, and reflected wave as well. So Vy and Iy you will get after incident and reflection. That means at steady state you will see Z in. But just as the switch is closed, at t equals to 0 plus, you will see Z node. Is that point clear? This is a very important point, and a lot of guys just remember it, that once you do the time domain analysis, then at t equals to 0 plus you will replace the circuit with Z node. But why you are replacing it with Z node? Because just as you close the switch, only V0 plus wave is going, only I0 plus wave is going. There is no reflected wave at t equals to 0 plus. I am talking at t equals to 0 plus, not at steady state. So at t equals to 0 plus, only V0 plus and I0 plus is there. So if only V0 plus and I0 plus is there, there is no reflected wave, then certainly they will only see Z0, not Z in. Z in we see at steady state. So at t equals to 0 plus, how will you replace your transmission line? At Z0 only. Because here it will see Z0, 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 then it will see ZL. And if it sees ZL, then it will be reflected back. So total here V0 plus will be there, I0 plus will be there, V0 minus will be there, I0 minus will be there. So total wave combined will see Z in. But if I only talk about V0 plus and I0 plus, then they will only see Z node. So at t equals to 0 plus, how will you replace your circuit? So at t equals to 0 plus, I will replace my circuit something like this, that there would be Vg, there would be Zg, and there would be this. I will be replacing with Z node. So how I can find my Z node? Sorry, this is my Z node. Z node will be given in the question. This has been mentioned 50 ohm, but it could be anything. So I am just writing it Z node. So how I can find my V node plus? What will be my V node plus? So my V node plus would be, because across the Z node, what V node plus is seeing? Z node. So this will be my Z node. This will be my V node plus. V node plus will be the voltage across Z node, right? So that will be given as Vg into Z node upon Z node plus Zg. And what will be my I node plus? My I node plus will be Vg upon Zg plus Z node. Basically, what is your I node plus? V node plus divided by I node plus is equal to Z node. So this will be my I node plus. So V naught and I naught, V naught plus and I naught plus both are seeing Z naught. So I just replaced my transmission line with Z naught. From there I could get the value of V naught plus as well and I naught plus as well. And if you divide both of them, you will get Z naught only, that you can directly see. This is your I naught plus, right? Well and good. So this is how I will find V naught plus and I naught plus. Like there will be further analysis as well, but as of now we are just seeing that how to replace the circuit at some particular time. That at t equals to 0 plus, how will I replace the circuit? Now at t equals to infinity, how will I replace my circuit? I will replace my circuit with Zin, because what is my Zin? My Zin is the total voltage divided by the total current. Here incident, reflected, everything is there. So then I will replace my circuit with Zin. So at t equals to infinity, transmission line behavior at steady state. That means after reflections, there are incident wave as well, reflected wave as well, again reflected wave, again reflected wave. So all the waves are there. If all the waves are there, then you replace your transmission line with Zin. Very, very important point. So at t equals to infinity, how will I replace my transmission line? So then I will be replacing it with Zin. And what is Zin? What is Zin? Zin is Z naught into ZL plus Z naught tan hyperbolic gamma L, but tan hyperbolic gamma L, yes, this is Zin, because the distance you have covered is length L, right, divided by, but 100% the line given will be lossless transmission line only. So here you will be writing J beta L, but as of now let's write it down in a general way, tan hyperbolic gamma L, because you will never have to do the hyperbolic calculations. So your Vs would be there. Your Vs voltage source is there. You will have the ZG impedance, and at steady state it will be replaced with Zin. Now Zin can have any nature, resistive, inductive, capacitive or complex. So here that voltage which I get, here some voltage I will be getting Vs. What that Vs would be? Can you tell me? Yeah, so what I was saying that I am getting Vs potential across Zin. So if I am calling this as Vs, I cannot call this as Vs. So I need to give some different name. So this I am calling as generator Vg. So this is our generator. This generator is having Vg potential and Zg input impedance. This is having Vg potential and Zg input impedance. And across Zin you are getting Vs. So till now what we have done, we need to analyze that behavior of transmission line at steady state. So at steady state we know that there will be incident wave as well, reflected wave as well. So effectively we will see Zin impedance from here. So that Zin impedance we will see, and now we can replace our transmission line with Zin. So across Zin, whatever the potential that you are getting, that will be given as Vs. So that will be, if you make this potential Vs in the transmission line, then this will be your Vs. And if I say that in my Zin Is current is flowing, that means in the Zg as well Is current will be flowing. So this will be your Is. So if you make this Vs and Is in your transmission line, then this will be your Vs and Is. Do you agree to this point? At steady state, I replaced my complete transmission line with Zin, because there will be incident and reflected all the waves, so that I can replace my transmission line with Zin. And then across the Zin, whatever the potential that I am getting, that is equals to Vs. So what is your Vs? Your Vs is equals to Vg into Zin upon Zin plus Zs, Zin plus Zg. Your Vs is equals to Vg into Zin upon Zin plus Zg. Simply potential divider I have applied, right? Okay. Also what it will be equals to? This is your Vy, but y equals to L, because this is your y equals to 0 and this is your y equals to L. What was your Vy? Vy was the voltage on transmission line at any random point. At any random point. Voltage on transmission line at any random point was your Vy. Now I am saying that voltage on transmission line at y equals to L is Vs. So that will be equals to Vy is equals to L. What that would be equals to? Do you remember the formula? VL cos hyperbolic gamma y. VL cos hyperbolic gamma y. But instead of y, what I am going to put? L. Plus IL Z naught sin hyperbolic gamma y, where y was the distance from load. So you are finding at the source end. Directly here you are finding. So directly here if I am finding, that means y equals to L I need to put. So this is my Vs. So to these kind of equation I am getting, that Vg into Zin upon Zin plus Zg is equals to this guy. So from there I can do my calculation. We will see the questions, but as of now we are building up the concept that if they are asking the steady state values Vg, Vs, Is, or they can ask VL, IL as well. So if they are asking steady state values, that means you need to replace your transmission line with Zin. And if you have replaced with Zin, then you can find Vs and Is. What will be your Is? Is will simply be Vg upon Zin plus Zg. And that would be equals to I when Y is equals to L. So IL cos hyperbolic gamma L plus VL by Z naught sin hyperbolic, sin hyperbolic gamma L, sin hyperbolic gamma L plus sin hyperbolic gamma L. So this will be your Is. Are you able to understand this point? I hope this is clear. At t equals to infinity, at steady state, we will replace our transmission line with Zin because their incident and reflected waves are there. If I replace it with Zin, then which will be my Vs, which will be my Is. So simply by potential divider and using the concept of current, simply using the Ohm's law, I have written these equations, right? And then how I can write it down in the equation of transmission line. So in the equation of transmission line, we have studied that voltage at any random point on transmission line is given as Vy, where Y is the distance from load, and the formula was VL cos hyperbolic gamma Y plus IL Z naught cos sin hyperbolic gamma Y. But here Y is equals to L because we are finding right at the source end. Right here we are finding. Okay. So this is the analysis. Using this analysis, we will solve a lot of problem. So let's write down the summary only, that here some Vg and Zg would be there. So from there you can find the value of Vs and Is. So what is your Vs? Vs is the Vy potential only, but at Y equals to L. What is your Is? Is is the Iy potential only, but Y equals to L. What is your VL? VL is the Vy potential only, but Y equals to 0, because this is the end of transmission line and we always do our calculation from the load side, right? And what is your IL? IL is the I only, Iy expression only, but at Y equals to 0. Is that clear to you? And what is your Vy and Iy? Your Vy is VL cos hyperbolic gamma Y plus IL Z naught sin hyperbolic gamma Y. And what is your Iy? Iy is IL cos hyperbolic gamma Y plus VL by Z naught sin hyperbolic gamma Y. Okay, gamma Y. And if you talk about lossless transmission line, if you talk about lossless transmission line, that means for lossless, cos hyperbolic gamma Y will be replaced with cos beta Y, and sin hyperbolic gamma Y will be replaced with J sin beta Y. So if I need to write down the Vy expression for lossless transmission line, that would be VL cos beta Y plus J IL Z naught sin beta Y. And if I need to write down Iy, that would be IL cos beta Y plus J, this is IL Z naught, VL by Z naught sin beta Y. So 100% chances are there that they will give lossless transmission line only, because you will never have to do hyperbolic calculation. So lossless transmission line only will be given, and there you need to apply these equations. With respect to Y equals to L, you can put, if you want Vs and Is, and if you want at load, you can put Y equals to 0. Okay. So these equations we have studied, a very important equation. And till now, what is the summary? That if you need to analyze at t equals to 0 plus only, then you will replace your transmission line with Z naught, because there will be only V naught plus and I naught plus. But if you are analyzing at steady state, then there will be incident, reflected, all kind of waves will be there. So if all kind of waves are there, that means you need to replace your transmission line with Zin, because Zin is Vy by Iy, but Z naught is V naught plus divided by I naught plus. Then you will replace it, then you can find Vs and Is, and in the equation that we already know, Vy and Iy, you can put Y equals to L and for voltage, and Y equals to L for current. Okay, and then you can do your analysis. Okay, so let's solve the problem now. So here in this question, what is given, that I can tell you. This is the transmission line, 50 ohm lossless transmission line is there. The length is 0.15 lambda. VL and ZL, ZL is given, that is 75 ohm. You need to find VL and IL. Along with that, you are having a generator which is having 300 volt. Like this is your maximum value only. This is how it will be mentioned, that Vg, and then they can say bar. This is basically, this is some 300 sin omega t. This kind of potential is applied, which is having a peak value of 300 volt. So this is given, and then Zg is given, it is having its impedance as well. Generator is having its own impedance, that is 50 ohm, and this transmission line is given, switch is closed at t equals to 0. They are asking you Vs I in, this is your I in, the current that is going into your transmission line, VL, IL and Z in. These things they are asking. Okay. So this will be mentioned in the examination. Now what do you think, whether they are asking at t equals to 0 plus or at t equals to infinity? So if they are asking at t equals to 0 plus, then they would have mentioned v naught plus, or they would write it down that we are asking at t equals to 0 plus. Okay, they would write it down that analysis you need to do at t equals to 0 plus, or at some time as well they can ask, like at t equals to 1 microsecond, 2 microsecond. These things also they can ask. We will see these kind of questions as well. But for now, they have just written Vs and II. That means a steady state only, no? Like the switch is closed for a longer time, then a steady state incident reflection, all things will be there. Then what will be your value of Vs, II, Vl, Il and Zin? So from here, just by looking at the question, I can tell you that they are asking at steady state. They do not need to write it. There you need to understand that certainly they are not asking at t equals to 0 plus. So certainly they are asking at steady state only. So at steady state, what we are going to do? We are going to replace our transmission line with Zin. Look, the calculation will be a bit complex here. I can directly see that these are the answer. That's why I have written down the answer, because calculation will be complex. But for one time only, for practice purpose, you do the calculation. Like at least like complex calculation will help you in the examination, because certainly there will be 1-2 questions where you will be doing complex calculations. So try doing it. Try doing the calculation on your own. You know all the concept, but calculation will be a bit complex, but do it. Okay. So first we need to find Zin only, because our transmission line will be replaced with Zin. So first let's find Zin. Do you remember the formula? Since this is lossless transmission line, so directly I will be applying the formula Z naught, but I am not going to apply the formula. Z naught into ZL plus J Z naught tan beta L. What is the value of beta L that we can find? Beta L will be 2 pi by lambda and L is 0.15 lambda. So beta L will be 0.3 pi. So tan 0.3 pi divided by 50 plus J75 tan 0.3 pi. So if you solve this particular calculation, if you do this calculation, then this answer you will be getting. So I am not going to do the calculation, but you are an aspirant. I am an educator, you are an aspirant. So as an aspirant, you should do the calculation. So this answer you will be getting. This is your Zin. Okay. Now I need to find I in, Vs, all these things. So for that, I can replace my transmission line with input impedance, that is Zin. Okay. So now I am going to replace my transmission line, which is having Zg impedance 50 ohm. I will replace it with Zin. And here you are having 300 volt. What this would be equals to? This would be equals to your Vs, right? This would be equals to your Vs, and what will be your I in? This will be your I in, or you can say this will be my I in, and the same I in will be going into Zin as well. So what we can find? Let's first find I in only. Okay. And what is my Zin? 41.25 minus J 16.35. 16.35. Here did I put degrees? Why I am putting degree? This is not a degree here. So I in, if I find, that would be equals to 300 volt. This is just calculation now. This is just mathematics. 300 volt divided by total impedance, that is 50 plus 41.25 minus J 16.35. So now I just need to do the calculation. So what I will be getting? 300 divided by 91.25 minus J 16.35. So I need to find the angle and magnitude of this. So first let's find the magnitude. What that would be? 91.25 whole square plus 16.35 whole square under root. So 92.70. So magnitude we are getting is 92.70. And if I talk about the angle, let's find out the angle. So what will be the angle we will be getting? 16.35 divided by 91.25 tan inverse. So angle we are getting 10.16 degree, but here it would be negative because this is in the fourth quadrant. So minus 10.16 degree. If it goes upward, this will become positive because this is in the denominator, right? This is in the denominator. If it goes upward, it will become positive. So let's find the magnitude. 300 divided by 92.70. So 3.23, roughly around this only we are getting 3.24, 3.23. 3.24 e to the power j 10.16 degree. So this is your I in. Okay. So I in we have got now. So at least these kind of calculation you should be able to do. Like they can mention Z in on their own in the examination, because this will be a bit complex. But if they mention Z in, then at least this kind of calculation you should be able to do quickly. Okay. Now what we need to find? We need to find Vs. So for Vs you can apply potential divider as well, or directly what you can do is that my Vs would be equals to I in into Z in. I in value I am directly having 3.24 e to the power j 10.16, and for Z in this is my Z in. So this Z in also I will replace in polar form. This Z in I will replace in polar form. What do I mean by polar form? That I will write down the magnitude and the angle. So this I in I am keeping as it is. Now here I will write down the magnitude. What will be the magnitude? 41.25 whole square plus 16.35 whole square under root. So magnitude is coming out to be 44.37. 44.37. And if I talk about the angle, that would be 16.35 divided by 41.25 tan inverse, that is 21.62, but negative 21.62. Yeah, okay, 21.62 but negative. Now what will happen? These magnitudes will be multiplied and angle will be added, right? So 3.24 into 44.37, so 143.75. 143.75. And what about the angles? They will be added. So 21.62 minus 10.16, but negative sign will be there. 11.46 minus 11.46. Yes, this is what we are getting, minus 11.46. So this is your Vs. Simple calculation is there. These kind of calculation you should be habitual with. So you need to know whether you need to convert it into polar form or complex form. So polar form calculation is always helpful. So I converted it into polar form and I got the value of Vs and II as well. I have got the value of Z in. Now we need to find VL and IL. For that, what we can do? If you know Vs and Is and you need to find VL and IL, so what equations you can apply? These equation, Vy. So with the help of these equations, now we are going to do something. And what we are going to do? Not L, it should be Y. IL Z naught J IL Z naught sin beta Y. And if I talk about Iy, that is equals to IL cos beta Y plus J VL by Z naught sin beta Y. Now here if I put Y equals to 0, Y equals to 0 means load. If I put Y equals to 0, that means load, at load condition, because Y equals to 0 is load. So if I put Y equals to 0, then I am not getting anything, because if you put Y equals to 0, what you are getting? VL only, because cos 0 is 1 and sin 0 is 0, sin 0 is 0, and here you are getting IL. So this is not giving me anything. But if I put Y equals to L, then I can think something will help me. What I mean to say is that if I put Y equals to L, that means we are coming at Vs and Is, Vs and I in. At Y equals to L, what is your potential? Vs and I in, no? At Y equals to L. This is your Y equals to 0 and this is your Y equals to L. So if you put Y equals to L, then there could be something. Okay, so Vs and I in you will be getting. So for V at Y equals to L, that would be your Vs, and that would be VL cos beta L plus J IL Z naught sin beta L. Okay. Now let's solve it. Vs cos, what is the value of beta L? Beta L we have already calculated here, that is 0.3 pi. So VL cos 0.3 pi plus J. We are not having the value of IL. So how I can replace my IL? IL is simply VL by ZL, right? IL is simply VL by ZL. Right, here you can see IL is VL by ZL. So that I can replace with, yeah, so what I can write is that VL by ZL. What is ZL? ZL is 75. ZL is 75 ohm into Z naught is 50 sin 0.3 pi, right? Sin 0.3 pi. Sine 0.3 pi. So what you are getting? Cos 0.3 pi. So 0.3 into pi cos 0.587. So 0.587 or 59 I can write VL plus J. Now VL will be there as it is. Now numerical value only I need to put. So 0.3 into pi sine into 50 divided by 75. So 0.54, roughly around 0.54 you are getting. That is your JVL. And what is the value of VS? VS already we know. VS is 143.75. So now only VL is left. My target was to make the equation only in terms of VL. Now I can find VL very easily, right? So now you might be thinking that, sir, very complex calculations, so these kind of questions will not be asked. So we can skip this concept. You cannot skip the concept. Like here the calculation are pretty complex because this is a standard question. I just picked the standard question from a textbook. Okay, but these kind of questions in a easier manner can be asked. And I will tell you one gate PYQ as well. On this concept only gate PYQ was also asked. Gate question has been asked, but they will frame the problem in a manner that calculation will be easier. But certainly concept is important. What is the concept at steady state? Replace with Z in VSIS you find, and with respect to VS and IS you apply the equations, you manipulate the equation and get the value of VL. So from here I can directly tell that my VL will be 143.75 e to the power minus j 11.46 degree divided by 0.59 plus j 0.54. So what I'm gonna do is that 143.75 again I will convert it into polar form only. 11.46 degree 46 or 45 46 divided by, let's convert that into polar form. So square plus 0.59 square and then take the under root. So 0.8 you are getting here. 0.8 e to the power, now the angle. So angle will be 0.54 divided by 0.59 tan inverse. So angle is 0.74. Are we nearing the same thing? No. Okay, angle is not 0.74, that is in radian. So I forgot to convert it. So again, let's calculate the angle. 0.54 divided by 0.59 and then in degree I need the angle. So 42.46. Angle is 42.46 degree. So now what will be your VL? VL is 143.78 divided by 0.8. 143.78 divided by 0.8. So roughly around 180 only you are getting. 180 e to the power minus j, then angle, this will be going upward and negative. So negative negative both will be added. So 11.46 and 43, that would be 53, roughly around 54. So this is what we are getting. Yes, 180 minus j 54. So yeah, we are getting this answer VL. So this is our VL. That's it. Okay, it was very easy problem only. It was not tough. Just you need to manipulate these equations. This was the most important concept, that if you put y equals to 0, you are getting VL IL, you cannot do anything. But if I put y equals to L, then I can change it in terms of only VL, and IL I am replacing with VL by ZL. Now what is my task? IL. IL is VL by ZL. So again I am not going to apply this IY equation. You can solve from IY equation as well, but why should I apply that? Because I know that my IL is VL by ZL, and VL expression I am already having, divided by ZL. What is ZL? ZL is 75. So divided by 75. So 180 divided by 75. So 2.4 roughly around 2.4. Yeah, 2.4. 2.4 e to the power minus j 54 degree. So these kind of easy questions can be asked to you, but you just need to know that this analysis we have done at steady state, and if we have done this analysis at steady state, that means we will start by replacing Z in, then we will find the value of Z in, then we will find I in and Vs, and then in the equations we can replace the things and we will get our answer. Okay. Now let's solve the next question, and this you can do on your own. Try doing it on your own. You need to find maximum voltage, current and impedance on transmission line. Along with that, you need to find minimum voltage, current and impedance on transmission line. Which concept you will use here? You will use the concept of standing wave, right? Because what will be your maximum voltage? Your maximum voltage will be your Vmax. What will be your Vmax? Your Vmax will be V0 plus 1 plus mode of gamma L. Gamma L you can calculate. very easily. 100 minus 50 divided by 100 plus 50. That will be 50 by 150. 100 minus 50 divided by 100 plus 50. So 50 by 150. So that is 1 by 3. So mode of gamma L is also 1 by 3 only. So your answer will be 1 plus 1 by 3. That will be 4 by 3 V naught plus. But how will you get this V naught plus? Now this is the task. And for what will be your I max? I max will be I naught plus 1 plus mode of gamma L. So that would be equals to 4 by 3 I naught plus. How will you get this V naught plus and I naught plus? So for getting V naught plus and I naught plus, that means from here if V naught plus comes in and from here if I naught plus comes in, what they will see? They will see Z naught. So now you will be replacing your circuit with Z naught. So did you get to know whether we will replace with Z naught or Z in? In the previous question we replaced with Z in because they were asking Vs and Is. But in this question we require the value of V naught plus and I naught plus. And V naught plus and I naught plus will see only Z naught. So now we are going to replace our circuit with Z naught. So this is our battery. Battery of 200 volt is applied, right? 200 volt battery is there. This is ZG. This should not be a battery, right? 200 volt battery cannot be there. This has to be a AC source only. So let's make it AC source only. Okay, this is not a battery. I am saying that this is a peak value. This is your peak value 200 volt. Okay. It is having, this is the peak value 200 volt. Okay, and this is your ZG 25 ohm, and I will replace with Z naught, not with Z in. Although length is also not given, so you cannot find Z in. But in the examination, what if they mention the length? Then you will be feeling like that sir, whether should be replaced with Z in or Z naught. Okay, if length is given. So just for making it a bit complex, I will mention the length as well. Then since the length is lambda by 2, so some student will be thinking that I will replace it with 100 ohm, because lambda by 2 length is there. That means complete ZL will be transferred here. So you will be replacing with 100 ohm and you will be getting it incorrect. So for correct would be you need to replace it with 50 ohm. Okay, so this is your 50 ohm and this is your 25 ohm, and whatever the voltage you get with respect to this, that will be your V naught plus. So V naught plus will be 50 by 50 plus 25, that would be 75 into 200. So 50 by 75 into 200, 133.33. 133.33. So this is your V naught plus. So what will be your V max? V max will be V naught plus into 4 by 3, right? Into 4 by 3. Into 4 by 3. So 177.77 volt. That will be your V max. And what will be your I max? Your I max will be I naught plus into 4 by 3, and that will be V naught plus into 4 by 3 divided by Z naught. Because what is your I naught plus? I naught plus is V naught plus divided by Z naught. And what is the value of this one? 177.77. 177.77 divided by Z naught. What is the value of Z naught? Z naught is 50 only. Or you can calculate from here as well. Like this will be your I naught plus, no? So I naught plus will be simply 200 divided by 75. So if you do 200 divided by 75, then you will get some answer. 200 divided by 75, you will get some answer, that is 2.66. And if you do this calculation, then also you will get the same answer. 177.77 divided by 50. Here we are getting 3.55. But what I could have done is that, or I could have done, first I could have found out the value of I naught plus. I naught plus would have been 200 divided by 75. And then if I need to calculate I max, what I would be doing, 200 divided by 75 into 4 by 3. So 200 into 4 divided by 75 divided by 3. So 3.55 only we are getting. Okay. So anyway you could have seen it. Basically your I max would be V max divided by Z naught. That's it. What will be the minimum values? Minimum value. This is your maximum ampere. This is volt. So this answer we have got and this answer we have got. What will be the I minimum or V minimum first? So your V minimum would be V naught plus into 1 minus gamma L, right? So what is gamma L? Gamma L is 1 by 3. So that would be 2 by 3 V naught plus. So this was your 4 by 3 V naught plus, this will be 2 by 3 V naught plus. So simply half of this will be our answer, because 4 by 3 V naught plus, and if you need to calculate 2 by 3 V naught plus, that means you just need to take half of that. So 177.77 divided by 2. So 88.88 volt. So this is your V min. And if I need to calculate I min, then I min also will be equals to I naught plus into 1 minus gamma L. So that would be 2 by 3 I naught plus. Okay. So 2 by 3, this was your 4 by 3 I naught plus. So this was 3.55. So simply half I need to take. So what I will be getting? I min will be equals to 3.55 divided by 2. 3.55 divided by 2. So 1.77. 1.77 ampere. This is what I am getting. Okay. Now if I need to find what I need to find, maximum and minimum input, minimum and maximum impedance, not input impedance, just the impedance I need to find, maximum and minimum impedance. So what I will be doing, Z max, if I am finding, that means V max divided by I min, V max divided by I min. So what is my V max? V max is 177.77, 177.77 divided by I min. I min is 1.77, and it should come out to be 100 ohm only. Why is that so? 177.77 divided by 1.77, it would be 100 ohm only. Why is that so? Because where you will get your Vmax and I min? Here only, no? This will be your Vmax, because here your gamma L is positive. This you are getting as 1 by 3. So gamma L is positive, load is resistive. That means at load only I will get my maxima. So this will be my VL, Vmax. VL will be my Vmax and this will be my IL. So VL will be your Vmax only and IL will be your I min only, because at the load you will get a maximum voltage and minimum current. Are you getting this point? And somewhere at lambda by 4, and what will be lambda by 4? Right in the middle. Somewhere here in the middle you will be getting V min and I max, right? So that will be your Z min. So these things they can ask. This you will be getting at load or at a lambda by 2 distance. That means here you could have got your maximum here as well. You could have got at load or here, because after lambda by 2 same thing will be repeated, but minimum you will get somewhere in between. So this is your V min by I max. V min by I max. So V min divided by I max. So what that would be equals to? What is your V min? 88.88 divided by 88.88 divided by 3.55. 88.88 divided by 3.55. 25. So what you are getting? 25 ohm. So this will be your minimum impedance, this will be your maximum impedance. Okay. Z max and Z in. They are not asking input impedance, they are just asking minimum and maximum. Input impedance will be 100 ohm only, because here what you will be getting? Again you will be getting your maxima voltage and minima current. I hope you must have got the point. Now let us say if this length was mentioned as lambda by 8. If this length was mentioned at lambda by 8 and I would be asking you what is the minimum impedance on transmission line, what you would be telling? The length was mentioned lambda by 8 and now I am asking you what is the minimum impedance on the transmission line? Will your answer would be 25 ohm? No. Why is that so? Because 25 ohm, 5 ohm will not even be received. Why is that so? Because 25 ohm will be received at lambda by 4 distance. 25 ohm will be received at lambda by 4 distance. If the length is lambda by 8, then at lambda by 8 you will have your minimum impedance. At lambda by 8 you will have your minimum impedance. That means what you are going to find? You are going to find Z in. And you will apply the formula. What will be my minimum impedance if the length was lambda by 8? That would be Z naught into ZL plus J Z naught tan beta L, and tan beta L will be 1 because length I am taking as lambda by 8. So if the length was lambda by 8, let's write it down. Okay. If the length of the line was lambda by 8, if follow up question, okay, follow up question, if length of transmission line was lambda by 8, then what would be your Z min, Z minimum? So Z min is occurring, this is occurring at lambda by 4, because at load you are having maxima, then after lambda by 4 you will have your minima. But that will not happen, because what will be the standing wave pattern? This will be the standing wave pattern. If I make the standing wave pattern, so maxima, and only this much length is there, no? Only this much length is there. Only this much length is there. And sorry, the minimum value will not be 0. Minimum value will not be 0. So this is how the standing wave pattern will look like. Okay. This length is lambda by 2. This length is lambda. So this is the voltage standing wave pattern. Okay, this is the voltage standing wave pattern. What is the Vmax and Vmin? Vmax and Vmin is 177.77 and this is your 88.88. 88.88. And if I make for the current on this one only, if I make for the current, so if I make for the current on this one only, then it will look a bit complex, but let's make it for current. Here I am making, okay, this will be for the current, or let's use the other color of pen. This will be your standing wave pattern for current. So for current you are having minimum value equals to, this distance will be 0, this distance will be lambda by 4 and this distance is lambda by 8. So you are having your minimum value as 3.55. Now maximum value as 3.55 and minimum value as 1.77. 1.77 and 3.55 ampere. So now if the length is lambda by 8, that means you are somewhere here. So at lambda by 8 only you are having your maximum current and minimum voltage, right? At lambda by 8 only. If the length is lambda by 8, that means these things are not even achieved. You are somewhere here only, if I talk about lambda by 8. So at lambda by 8, what do you see? Whatever the current you are having, that is maximum current, and whatever the voltage you are having, that is maximum voltage. What I mean to say is that if the length was lambda by 8 only, then this is what you would be getting. If the length was lambda by 8, this is the answer. So for voltage you would have reached only till this point, and for current you would have reached only till this point. So voltage is decreasing, current is increasing. So this length I am calling as lambda by 8. Okay, this magnitude is 177.77 volt and this magnitude is 1.77 ampere. 1.77 ampere. Okay, and this we need to find. So this will be equals to input impedance, because on transmission line which length you have covered? Lambda by 8 length you have covered. On transmission line you would have covered complete lambda by 8 length, with your load being 100 ohm and this Z node would have been 50 ohm, right? This would have been 50 ohm. Yeah, so this will be only your Z min. Why is that so? Because at this point, at lambda by 8, you are having your maximum current and minimum voltage. So Z min will be equal to your Z in only. And what will be your Z in? That would be equal to Z naught into ZL plus J Z naught tan beta L, and value of tan beta L will be 1. Because this we have already seen. Beta L, 2 pi by lambda into lambda by 8. So beta L value will be pi by 4 and tan pi by 4 is 1. Divided by Z naught plus J ZL. So better applying the formula, we will just write it down. Z naught into, what is the value of Z naught? Z naught is 50. 50 into ZL plus J Z naught upon Z naught plus J ZL. So 50 I can take from here. If I take 50 common, then this get cancelled. So we are getting 100 plus J50 divided by 1 plus 2j. So rest you can solve, like whatever the option is mentioned, you can click on that. So this will be your minimum input impedance if the length is lambda by 8. So blindly if these kind of questions are asked, this is a very good conceptual question. So blindly there you will not be saying that, sir, okay, for minimum what I'm gonna do is that V min and I max. No, for Z min you need to see. And what if this was 25 ohm? If this load was 25 ohm, then minimum impedance would have been 25 ohm, because at the load what you would be getting, if this was 25 ohm, that means your gamma L would have been negative. If gamma L is negative, that means at the load I will be getting my voltage minima and current maxima. That means this will be the condition of my lowest impedance. So 25 ohm will be the lowest impedance. If I need to get the highest, then I need to check the voltage maxima and current minima. So there I can get the highest. And if the length was lambda by 8 only, then highest condition will not even be achieved, and I just need to find input impedance. So for input impedance, I will apply the formula Zin equals to Z naught into ZL plus J Z naught divided by Z naught plus JZL. So I hope you are getting the concept, what we are doing here. So if the picture are clear, if all the concepts that I am teaching, if all those concepts are clear, then you will never find difficulty in solving any problem of transmission line. So these kind of questions certainly you will get in test series, but here we are just framing these kind of questions, and concept I have given completely. That all the things should be in your mind, that how the voltage standing wave pattern will look like, how the current standing wave pattern will look like, and where you will get maxima, where you will get minima. So in this particular question, the length was lambda by 2 mentioned. So length was long enough. If the length is long enough, that means you will get minima as well and maxima as well. So in the question, length has to be mentioned, because if length is not mentioned, then you will be thinking that whether you will get minima or maxima. Like if here I did not mention the length, then what you would be thinking? Then that you would be thinking that, sir, it's not necessary that you will get minima condition, because what if the length is lambda by 8? So if the length is lambda by 8, then Z minimum is different, but here Z minimum was 25 ohm. So that's the thing. Okay, so I hope the concept is clear. Your concept will be only clear if you have followed the previous videos as well. In the previous video, I have spent a lot of time on standing wave pattern, and before that as well, I have spent a lot of time on standing wave when we were studying EM waves. So from EM wave, we are building up the concept. Now you are certainly feeling very good about this particular chapter, right? So now we need to see more concept. Now we will see that transient analysis. Like transient analysis means we will do the analysis at t equals to 0, at t equals to tr. What is tr? Transit time at t equals to 2r. What was your tr? Tr was L by Vp. So that analysis we will do, but we need to take a break in between. I will take a break. Probably I will eat my food, and if this is the food time for you, then you should also have the lunch or dinner. Currently it is the lunch time for me, so I will go and have my lunch, then I will come back and we will see the transient analysis. In transient analysis, we need to do the analysis at a certain time, like at tr to tr. We have seen the analysis at t equals to 0 plus, at t equals to steady state. At steady state, we have seen the complete analysis, we have solved the problem as well. But at t equals to 0 plus, at t equals to tr, at t equals to 2tr, those analysis we need to do. So now we are going to see this particular analysis, but after a break. Okay, thank you very much. Yeah, so let's start our second half of this video. Now we need to do the transient analysis of a transmission line. That means at a particular time instant also I need to tell the value at, they can ask me the value at load as well, or somewhere in between, or at the source end as well. Okay, so at a particular time instant. So now what will happen, just as you close the switch, what will happen? V naught plus will get out from here. Okay, now this V naught plus will get out from here and it will travel. It will travel through the transmission line. So this V naught plus will start traveling through the transmission line, and then it will reach to the load. How much time it will take to reach to the load? Transit time, right? What is the transit time? Transit time is the time taken to cover this distance divided by the speed, and the speed will depend on the medium, right? L by Vp. What is the formula of Vp? That also you know, omega by beta. And what is the formula of L is simply the length. So this transit time will depend on the speed, also on the length. So it will take a finite time to reach here, and that time I am denoting as t, not tr, I am denoting at t. So at t you will have, this is the time t, at t you will have V naught plus at the load. Now what this load will do? This will have some reflection coefficient. This will have some reflection coefficient. So reflection coefficient gamma L would be there. That would be ZL minus Z naught upon ZL plus Z naught. So what this load will do? This will reflect back this V naught plus waveform. And what will be the amplitude of this reflected wave? Gamma L plus V naught plus, right? V naught plus was coming, it will be reflected back by the load. So now it will go back. So it will go back in this manner. So gamma L V naught plus. Now it will start traveling back in this manner. It will be reflected back like this. So here, this was your time t. At 2t it will reach, at time 2t, what will reach here? Gamma L V naught plus. V naught plus was going, then at time t it was reflected back. So gamma L V naught plus was reflected back. So at time 2t, gamma L V naught plus has reached. Okay. Now gamma L V naught plus is reflected back by Zg. Gamma L V naught plus is reflected back by Zg. Because in the same manner, here there is reflection coefficient. So here also there will be a reflection coefficient. What that is given by as? So this is the reflection coefficient at load end. This is the reflection coefficient as source end. So that is given as Zg minus Z naught upon Zg plus Z naught. So this is a new thing for you. But you need to remember, the same way at the load you are having a reflection coefficient, in the same way at the source also you will have some reflection coefficient. So this gamma L V naught plus will be reflected back. Gamma L V naught plus will be reflected back by how much amount? It will be multiplied with gamma G. So gamma G, gamma L V naught plus. Now the wave which is reflected back, this will have this much of amplitude. Okay. So now it is reflected back and it is going in this manner. This I am talking about only voltage. The same thing will be happening with current as well. So now here what has reached? Gamma G, gamma L V naught plus. And at what time it will reach? This was the time t, then it took 2t time, then it would take another t time. So at 3t it would have reached. Right, which started time t, then 2t, here you are having gamma L V naught plus, then gamma G V naught plus, that will reach as at 3t. Now what will happen? Again gamma L will be reflecting back this wave. Again gamma L will be reflecting back this wave. So for now here your amplitude will be gamma L, gamma G, gamma L square. Why is that so? Because it is reflected by ZL with the reflection coefficient of gamma L. So V naught plus came, then it was reflected back and amplitude became gamma L V naught plus, then it reached here, then it is reflected back, gamma G, gamma L V naught plus, then it has reached here, then again it is reflected back, it has reached here with the amplitude of gamma G, gamma L V naught plus. Now again it is reflected back, so it will have the amplitude of gamma G, gamma L square V naught plus. So here it will have the amplitude of gamma G, gamma L square V naught plus. Now what will happen? Again it will be reflected back. Again it will be reflected back. Now this again it will be reflected back and will be reaching towards the load. Again it will be reflected back and will be reaching towards the load. What will be the magnitude? The magnitude will be gamma G square, gamma L square V naught plus, because it is reflected with gamma G. So let's make the clearer diagram. What is happening here? Initially you started with V naught plus. Initially you started with V naught plus. Initially you started with V naught plus at time t equals to 0. At time t equals to 0. And at time t equals to t you would have reached here. Then what happened was, this load end was having your gamma L reflection coefficient. This we are making for voltage. So this is known as bounce diagram. Okay. This diagram which I am making, it has a certain name. The name is not important. Just it is known as bounce diagram. This diagram is known as bounce diagram. So voltage bounce diagram we are making. So now what happened was, at t equals to 0 we started with V naught plus amplitude. Now here it will be reflected back at the load end by the gamma L coefficient, it will be reflected back. So the amplitude will be gamma L V naught plus. Now again here at time 2t we will reach, right? Because this distance is L. This distance is L. And you need to go with the speed Vp. So what will be the time t? T will be L by Vp. Okay. So at 2t you would have reached here. Then at 3t you would have reached here, because this will be reflected back with the reflection coefficient of gamma G. So gamma L, gamma G, V naught plus. Then again it will be reflected back. So this will be, now this time from 0 to t, t to 2t, 2t to 3t. At 3t time we will reach here. Then at 4t time we will reach here. What will be the amplitude? That would be V naught plus, gamma L V naught plus, then gamma L gamma G V naught plus, and again it will be reflected back. So gamma L square, gamma G V naught plus. Then again it will be reflected back. again it will be reflected back. So what will be the amplitude? The amplitude will be gamma L square, gamma G square V naught plus. Then again it will be reflected back. Then this cycle will keep on going in this manner, right? This cycle will keep on going. So let's make it till here. So again it will be reflected back, again it will reach, then this reflection will keep on going. So here what I will be getting, gamma L square, not gamma L square, gamma L cube, gamma G square V naught plus. So at t equals to 0, this time would be 5t. So at t equals to 0, V naught plus was generated. At t equals to 0, V naught plus was generated and it traveled to the load till time t. It took a time t to reach here, V naught plus. Now it is again reflected back. If it is reflected back, now it will take another time t to reach here, right? Now if I ask you the voltage at y equals to 0 and time t equals to 0, not y equals to 0, sorry, it would be y equals to L. What I mean to say is that y equals to L means this is my y equals to 0, this end is y equals to 0 and this end is y equals to L. So voltage at y equals to L, what is my y equals to L? This is my y equals to L. This is my y equals to L and this end is y equals to 0. So voltage at y equals to L and at time t equals to 0, what will be the voltage? V naught plus. Because at that time only V naught plus is generated. Now if I ask you voltage at y equals to L only, but at time equals to t, time equals to t. So at time equals to t, what is happening? This guy is generating gamma L V naught plus. At time t equals to t, at load you have generated gamma L V naught plus. Because V naught plus has reached here, or you can say at t equals to t plus. At t equals to t plus, gamma L V naught plus has been generated. But this hasn't reached here. This gamma L V naught plus will take another time t to reach here. So at time t, at this end only you are having V naught plus only. Here in this diagram also you can see, we started with V naught plus. But at 2t you will have gamma L V naught plus. Are you getting this point? At time t, here first reflection took place. But at the source end only V naught plus you are having. So here you are having only V naught plus only. Are you getting this point? And if I ask you the voltage at y equals to L at t equals to 2t plus, I am asking, okay, just after 2t, what that would be? Here at this node, what will be the voltage at 2t plus? Write it down on your own. What will be the voltage? So the voltage will be V naught plus gamma L V naught plus gamma L gamma G V naught plus. Why is that so? Look, V naught plus was there at time t, this reached here, now it is reflected back by the load gamma L V naught plus, now it is reached here. Now gamma L V naught plus at time 2t has reached here. Along with that, it is reflected back as well. So if I ask you at a time t equals to 2t, then all these three things are there, right? At time t equals to 2t, at time t equals to 0, V naught plus was there. Then some voltage came, gamma L V naught plus at time t equals to 2t. At t equals to 0, V naught plus was there. It took time t to reach here. That would be gamma L V naught plus. Now again it is reflected back. So again it took time t. So t plus t 2t. So at 2t time you are having gamma L V naught plus as well. Now at that time only some reflected wave also came in. This reflected wave also came in. So what all voltage you are having? V naught plus was already there. Then gamma L V naught plus was already there. Then gamma L V naught plus will also be there. Now don't think that, sir, this V naught plus was initially there, so it traveled down. So here V naught plus is gone. No. This is a traveling wave. V naught plus will certainly be there. Do you remember traveling wave? It will generate some amplitude, but the amplitude will, like energy will keep on moving. But certainly here also there will be some energy. It's not that sir, you started from here, then after some time it will reach here, then after some time it will reach here. No. I hope you remember that simulation. There the wave will keep on generating ahead. Like the wave will keep on generating. So here also there will be energy. At time t equals to t, energy will be here, everywhere will be the energy. At time t equals to t, what I am saying, at time t equals to t, energy will be here. So the diagram that I made, that means energy will be at all the points. And at time t equals to 2t, reflected wave is also coming, then again reflection is there. So this energy and this energy, all three energy will be there. So from now onwards, from bounce diagram only we will be solving the problem. From bounce diagram, that what we will be saying, at t equals to 2t, what we can see? We can see V naught plus, gamma L V naught plus and gamma L gamma G V naught plus. Now V y equals to L at t equals to 3t if I ask. Where will be 3t? Here there will be 3t. This time will be 3t. This is the time 3t. So at 3t what you can see V naught plus gamma L V naught plus and gamma L gamma G V naught plus only. Because at t equals to 3t you have reached here. Now again it will be reflected back and at 4t you will be reaching here. So this time will be 4t. So at 4t something new you will get. So that time will be 4t, not 3t. So at 3t as well it will be same as Vy equals to L. That was the scene as 2t. At 3t by 2 also it will be same, but at 4t the scene will change. So what will be the voltage at y equals to L at time t equals to 4t? So at 4t you will be having V naught plus, along with that you are having gamma L V naught plus, along that you are having gamma L gamma G V naught plus, along with that from load as well something is coming, that is gamma L square gamma G V naught plus, along with that you are having this thing as well, gamma L square gamma G square V naught plus. Are you getting this point? So at t equals to 0 if they ask, only V naught plus is there. At t equals to 2t if they ask, then V naught plus gamma L V naught plus gamma L gamma G V naught plus, all these three things are there at t equals to 2t. If they ask at t equals to 4t, that means all these 5 are there. So what you will do in box diagram, you will go to 4t and you will see, okay, this wave and this wave is there, this wave is there, and lower waves will also be there. Now if I ask you the same thing at load end, okay, so I need to add a page. What I am asking the value of V at y equals to 0 at time t equals to 0. What will be the value? 0 volt. Why is that so? Because at the load, this is your y equals to 0, at the load, first wave came at a time t equals to t. If I ask you the value of voltage at y equals to 0, but at time t equals to t by 2, that will also be 0, because the first wave came at time t equals to t. So if I ask you the voltage at y equals to 0, but at time t equals to t plus, so at t plus what happened? V naught plus also came, along with that reflected wave was also there. This reflected wave was also there. So V naught plus was there, along with that gamma L V naught plus was also there. So V naught plus was there, along with that gamma L V naught plus was there. Now if I ask you the same thing at 3t by 2, what will be the scene at 3t by 2? So in Bausch diagram you can see that this will be my, this is 2t, so somewhere here you will be having 3t by 2, or you can write down 2t as well, because the next wave will come at 2t, sorry, next wave will come at 3t. So here I will be having my 2t. So at 2t what will be the scene? V naught plus and gamma L V naught plus only, because here I can see that the next wave will be coming at time 3t. So first V naught plus came, then at time t reflected wave was also there. So both of the things was there at time t. At time 2t this reached here, and at time 3t another wave started from here and reached here. So if I ask you the time, if I ask you the wave at time 3t, now if I ask you here also it will be same, it will be this guy only, because at 2t you are having only these two wave only. But if I ask you what will be the wave at time t equals to 3t plus, so on bounce diagram I will go to the 3t. So at 3t what I can see, this wave, this wave, this wave, this wave and this wave. So at 3t you are having all these 4 waves, and here also you can check at time t it reached, then at 2t, then at 3t this reached, and then reflected back. So at 3t you are having all these 4 guys. So V naught plus, then first reflection, then another reflection, then another reflection. Okay, so these 4 waves we are having. Well and good, this is at the scene of 3t plus. Right, now somewhere in between also I can ask, like somewhere in between means let's ask at L by 2, somewhere in the middle. So what will be the voltage at t equals to 0 at L by 2? Where will be L by 2? This spot will be L by 2 in the between. But if I make it, if I show it here, then diagram will be unclear for you. This will be L by 2 actually. Okay, just by one line I am showing. So I will remove this line because diagram will be unclear. Here the point will be L by 2. So now at time t equals to 0, what will be the voltage at L by 2? So at time t equals to 0, only the voltage was here. This voltage will reach at the midpoint. This is my midpoint. Here I can show. This is my midpoint, which is L by 2. So the wave will reach here after some time, and how much time, after how much time it will reach here? Can you tell me? It will reach here at t by 2 time, because it started from here and it need to cover the middle node. It has to come right in the middle of the transmission line. So to cover the complete transmission line, it is taking time t. To cover the distance L by 2, how much time it will take? It will take t by 2 time. So at t by 2 time it will reach here. So at t by 2 time you will be having V0 plus, right? So initially you are having 0 voltage, but at t by 2 time, if someone is asking you, at t equals to t by 2 time, if someone asks you, then you are having V0 plus here. Only the incident wave is there. And if I ask you the voltage at length L by 2, voltage at length L by 2 and time t equals to t, then what will be the voltage? V0 plus only. Why is that so? Because V0 plus traveled and reached here at time t. The reflected wave will be coming here at what time? At 3t by 2 time. Basically, initially at t by 2 time, V0 plus came. Then at 2t, what is the scene at 2t? This is the scene at 2t. Here, this is the scene at 2t. No, sorry. This is the scene at t only. Really sorry. This is the scene at t only. At t only, this reflected wave came into action. Now this reflected wave is going here. How much time it will take to cover this much window? T by 2 time. So at 3t by 2 time, you are having V0 plus as well and gamma L V0 plus as well. And how will you analyze here? So here you will say that, sir, this is time t equals to 0, this is time t equals to t. So this time will be t by 2. This is time t, this is time 2t. So middle distance will be 3t by 2. So this is 2t, this is 4t. So this will be 5t by 2. So at 3t by 2 plus or at 3t by 2 only, I am having V0 plus, along with that I am having gamma L V0 plus as well. So if I ask you voltage at L by 2 and at time 3t by 2, it is having V0 plus as well, along with that it is having gamma L V0 plus. If I ask you the voltage at distance L by 2 and at time 7t by 2, then what will be your answer? So this is 5 by 2, this is 3t, so this will be 3.5 by 2 or 7t by 2. So at 7t by 2, you will be having V0 plus, gamma L V0 plus, gamma L gamma G V0 plus and gamma L square gamma G V0 plus. So just looking at the bounce diagram without even drawing this diagram, you can tell everything. That if I am asking you voltage at time t at load. So you will see when time t is there, here is the time t. Okay. And now I need to see at the load end. So at load end, what all I see? V0 plus and gamma L V0 plus. So you will mark the time in this manner. This is time t, this is time t, this is 2t, this is 3t, this is 5t. Next will be 6t. And here also you can mark the time. This is t equals to 0, this is time t equals to 2t, 3t and 4t. Now if at any time I ask at 2t, so at 2t at the load end, what do you see? These two, that's it. At 3t if I ask, so all these I can see. At 4t if I ask, then below 4t what all things are there? These are there. If 5t if I ask, these things are there. Are you getting this point? And here also the same thing you can do. At t equals to 0 you can see only this, but at 2t you can see all these things. At 3t you can see only all these things. At 4t you can see all these things. At 5t also you can see all these things. And right in the middle if I ask, this is the time t by 2. So at t by 2 only you can see this. At 3t by 2 you can see all these three. At 5t by 2 you can see all this. If I ask you at 2t, where will be 2t? 2t will be somewhere in between. So at 2t as well you will see all these things only. If I ask you at 3t, so at 3t as well you will see all these three. At 3t what you will see? This wave and this wave. All these three you will see. At 4t, all these four you will see. So as of now I am asking at 7t by 2. So where will be 7t by 2? This will be 7t by 2. So in 7t by 2 all these things you will see. V0 plus, gamma L V0 plus, gamma L gamma G V0 plus and gamma L square gamma G V0 plus. So what all you can see? V0 plus, gamma L V0 plus, gamma L gamma G V0 plus 1 reflection, 2 reflection, 3 reflection and 4 reflection. So gamma L square gamma G V0 plus. So 4 reflections are there. Gamma L square gamma G V0 plus. Are you getting this point? Right? 4 reflections are there, right? V0 plus, gamma L V0 plus, gamma L gamma G V0 plus, and yeah, this will be your 3t by 2. So all these 4 reflections are there. So this is how I can mark my voltage amplitude. Same goes for current bounce diagram. So what will be happening? First I0 plus will be going. Now it will have its own reflection coefficient, but it will be current reflection coefficient, right? The reflection coefficient will be current reflection coefficient, and that is equals to minus gamma L voltage reflection coefficient. So I will always study with respect to voltage reflection coefficient only. This is my gamma L, which I am calling as voltage reflection coefficient. This is my gamma G. So that also I have written as voltage reflection coefficient. So always I find voltage reflection coefficient only, ZL minus Z naught upon ZL plus Z naught. So here also I am writing down all the things with respect to voltage reflection coefficient. So this I will be writing as minus gamma L. So from minus gamma L, what do you understand? From complete minus gamma L. This complete minus gamma L is the current reflection coefficient. Current reflection coefficient. And gamma L is the voltage reflection coefficient. Is that clear to you? So what I will do is that first I will find the reflection coefficient. I will write down the reflection coefficient here and here. Let's just say voltage reflection coefficient came out to be 1 by 3. So what I will write here? Minus 1 by 3. And let's just say this source voltage reflection coefficient. This is the load reflection coefficient, and source reflection coefficient is coming out to be 1 by 2. Let's just say this is the voltage reflection coefficient it is coming out to be. That means Zg minus Z naught upon Zg plus Z naught is coming out to be 1 by 2. So what I will put here? Minus 1 by 2. So now what I am going to do? I naught plus, then minus 1 by 3 I naught plus, then here again multiplied with minus 1 by 2, so it will be plus 1 by 6 I naught plus, then again it will be multiplied with minus 1 by 3. So we will solve those numericals, but as of now we need to write down in terms of gamma L and gamma G. So here you are having minus gamma L and here you are having minus gamma G. Okay, where gamma G stands for voltage reflection coefficient at source end, right? Are you getting this point? I am writing all the formula, everything I will write with respect to voltage reflection coefficient only. Is that clear to you? But I naught will be reflected with current reflection coefficient. It will be reflected with the current reflection coefficient, right? Current reflection coefficient at load L. Okay, it will be reflected back. Like what is the magnitude of I naught minus? I naught minus was gamma current reflection coefficient into I naught plus, and that too at a load. But I am not writing down my expression in terms of gamma I. I am writing down my expression in terms of gamma V. So I am talking about gamma V only here. So negative sign I need to put. Why negative sign came? I hope that is clear to you. We will solve the problem. In the problems, this negative positive will not be that much difficult for you, because there you will be getting to know that if you are calculating the voltage reflection coefficient, then for current reflection coefficient you just need to put a negative sign. So there it will not be that much problematic for you. But here, just for writing down the expression, this is how we will write it down. Then again it will be multiplied with gamma G. So gamma L, gamma G, I naught plus. Now again it will be multiplied with gamma L. So gamma L square, gamma G, I naught plus, but there will be a negative sign. Again it will be multiplied with gamma G. So gamma L square, gamma G square, V naught plus. Then again it will be multiplied with gamma L. So this will be minus gamma L cube, gamma G square, not V naught plus, I naught plus, sorry. I naught plus. I naught plus. So in that manner reflection would be keep on going. Is that clear to you? Why I am putting negative sign? Because this gamma L and gamma G are the voltage reflection coefficient. But for current reflection coefficient, we need to put a negative sign. We will solve the problem. It will be more clear to you. Do not worry about that. Now at any point, this started with at t equals to 0. This was at time t equals to t. This is at 2t. This is at 3t. This is at 4t. This is at 5t. Okay. Now we are writing steady state voltage. So steady state voltage we are writing at any point. So at steady state, how much voltage you will be having? Like initially it was V naught plus. This is at the source end. This was at the source. This was at source. All these were at source. And not source, sorry. Y equals to 0 you are writing. So this is the load end. All these were for load. This was the mid of transmission line, and all these was for source. All these expression you wrote for source. So at source, what you are seeing, first it was V naught plus, then V naught plus, gamma L, V naught plus, then gamma L, gamma G, V naught plus, then V naught plus, gamma L, V naught plus, gamma L, gamma G, V naught plus, gamma L square G. In that manner, voltage is increasing. So here what you can see, V naught plus, gamma L, V naught plus. So eventually this voltage you are getting. Same voltage you are getting here as well, right? Say like these kind of voltage you will get here as well. Initially V naught plus, gamma L, V naught plus. So this voltage, not the same expression, but you get to know that V naught, gamma L, V naught plus, gamma L, gamma G, V naught plus, gamma L square, gamma G, V naught plus, gamma L square, gamma G, V naught plus. Then what will happen? Gamma L cube, gamma G square, V naught plus. Then what will happen? Gamma L cube, gamma G cube, V naught plus. In that manner it will keep on going. Same goes here. Initially V naught plus gamma L V naught plus, then gamma L V naught plus gamma L V naught plus gamma L gamma G V naught plus, then gamma L square G gamma L square gamma G V naught plus, then gamma L square gamma G square V naught plus, gamma L square, then gamma L cube gamma G square V naught plus. In that manner voltage is increasing. Here also voltage is increasing. Initially this was there, then this was there, which is same as this, then this was there. So in that manner voltage is increasing. So at any point of on transmission line, voltage keeps on increasing, no? Like initially it was V naught plus, then one reflection will be taking place, then another reflection but from the source end will be taking place, then another reflection but from the load end will be taking place, then another reflection but from the source end will be taking place. So in that manner things will keep on going, right? From here load, source, load, source, load, then from source. In that manner things are going. So let's write it down, let's break it down. So this is your voltage at any point in steady state. Voltage at any point in steady state. Okay. So what I can do is that V naught plus gamma L gamma G V naught plus. What I am writing is that this we are taking aside. Okay. V naught plus gamma L gamma G V naught plus gamma L square gamma G square V naught plus, and in that manner more things will be there. And what else I am taking aside, that gamma L V naught plus, then gamma L square gamma G V naught plus, then gamma L cube gamma G square V naught plus, and then in that manner. What I am doing, this and this and this I wrote aside, and then this and this I wrote aside. Forget about the last one, forget about this one. Okay, forget about this expression. So more things will be certainly there, but we are not writing down all the steps. So here I can put a plus and dot 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 dot. Oh, more things will be there. So what I can do is that I can take V naught plus as common. So 1 plus gamma L gamma G plus gamma L square gamma G square plus dot 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 dot. Here what I can take, gamma L V naught plus as common. 1 plus gamma L gamma G V naught plus gamma L square gamma G square V naught plus. Now I hope you understood why I took that common, right? Because I can take gamma L V naught plus outside from here. Here I forgot to write why I am writing V naught plus here. V naught plus has been already taken common. Okay. So this is your V naught plus. Now what is the summation of this series? If you remember S of infinity, 1 plus AR square plus AR cube. What is the summation? A upon 1 minus R. But the condition is R has to be R has to be less than 1. This is the condition. Here R is less than 1. Here R is less than 1, no? Gamma L, gamma G. Gamma L is less than 1, gamma G is less than 1. Let's just say gamma L is 1 by 3, gamma G is 1 by 2. So this value will be 1 by 6, which is less than 1 only. So certainly it will be less than 1. So A upon 1 minus R. And here gamma L V naught plus is there. So what you will be getting? A upon 1 minus R. Same thing you will be getting minus gamma L gamma G. So if you add both of them, what do you see? V naught plus can come common. So 1 plus gamma L divided by 1 minus gamma L gamma G. So this is your voltage at any point in steady state. Not at load or anything like that, at any point. Now confusion will be coming into action. What will be the confusion? Now you will say that, sir, here we did the steady state calculation, no? In this question. In this question, we did the steady state calculation and we got this voltage at load, this voltage at load, and this voltage at source, and this voltage at source. This calculation is correct. Okay. Here, what we take in action is that there will be V naught plus and V naught minus. Only two reflected wave will be there. If you remember, how did we get this Vy formula? How did we get this Vy formula? Which formula? This formula. This formula we got when we did this calculation. that there is V naught plus e to the power gamma y, and since I am writing for lossless, so j beta y plus V naught minus e to the power minus j beta y. So there we took incident and reflected, that's it, nothing else. Then we found the value of V naught plus and V naught minus, and then we got this expression. Okay. So in the examination, if they are not saying that there are infinite reflection or anything like that, just at the steady state they are asking the value. So 100% at steady state, if they are asking the value, then you need to do this analysis. But if they are making the voltage waveform, like they can make the voltage waveform at certain time, and then they can ask you at a particular time what will be the voltage. So there they are saying that there will be multiple reflections. Are you getting this point? Here in this analysis, what did we do? We got this expression, we applied this expression here, and we got our steady state voltages. But there we considered that only incident and reflected wave are there, that's it. No further reflection, nothing like that. Only these two combined will give me this expression, and that formula I applied and I got this answer. Here what I am saying is that some wave came, reflected back, again, in that manner it is going, and total voltage we are calculating. So like this is not the actual correct answer at steady state, because what this is saying that at steady state a lot of incident reflected wave will be there, and all combined we are getting this expression. All waves combined we are getting this expression at steady state. V naught plus into 1 plus gamma L divided by 1 minus gamma L gamma G. So this will be our second attempt. If they are asking me steady state voltage at load or steady state voltage at Vs or at source end, then second we will apply this formula. First we will solve by this method. For steady state analysis, first we will replace with Z in. No, this is not steady state analysis. This is the steady state analysis. First we will replace with Z in, and we will find our Vs and II, and then we will find out our VL and IL. Here in this particular question, we are not going to find that, sir, first I will find my gamma L, then I will find my gamma G, then I will apply this formula V naught plus into 1 plus gamma L divided by 1 minus gamma L gamma G. So this I am gonna do when I am gonna do this thing, when I am not having, like, this is my secondary task. Here I can find everything, I can find Z in, right? I can find Z in, and then I can apply these formulas. But in the examination, if there is no chance of finding Z in, like length is not mentioned, then how will you find Z in, right? If length is not even mentioned, if there is no chance of finding Z in, then I will apply this formula for steady state calculation. And if they are asking the calculation for a particular time instant, then I cannot do anything. Is that clear to you? And certainly here there will be DC source. If they are asking that time domain calculation, so here they will put the DC source only. Like they will put a step function, they will apply the step input. But for this calculation as well, they can apply the step input, okay? For this calculation as well. For this which calculation? For this particular calculation. For here as well, they can apply a step input. But what is my priority? My first priority will be to solve like that find Z in, because I will take only incident and reflected wave in action, nothing else. But if in the question you get to know that there will be a lot of reflections and they are asking at the steady state voltage, they are asking steady state voltage considering all the reflections, then you will do this analysis. Okay. So both kind of questions can be asked, and both kind of questions have been asked as well. Okay. Both kind of questions have been asked. Like they only consider incident and reflected, or they consider incident, reflected, all kind of things. Okay. So by looking at the question, you will get to know that which formula I should apply. Are you getting this point? Is that clear to you? And if you need to find the steady state current at any point on transmission line, the previous discussion is clear or not? What did I say in the previous discussion? In the previous discussion, I said that there has been now two formula or two way to find the steady state voltage at any point of a line. But which way I will prefer? I will prefer the previous one. If they are asking for steady state, if they are asking for at a particular time, that let's just say at 2t time they are asking, at 2t time what is the voltage at the load? So certainly I need to apply this formula. At 2t time, if they are asking at 3t by 2 time, if they are asking what is the voltage at L by 2, then certainly I will have to apply this formula. There is no way. But if they are asking at the steady state, then previous analysis I will do. That's why I taught the previous analysis first, then I am teaching this analysis. So this will be my second priority if they are asking at steady state. But if they are asking at a particular time instant, then I will apply this formula only. Okay. Is that clear to you? All these things are clear. Now what will be your current? So current expression would be written as I naught plus, certainly what will be the answer? same expression you will be getting, just in place of gamma L, what you need to replace? Minus gamma L. Because what is gamma L? Gamma L is the, and what is the gamma G? This is voltage reflection coefficient. Voltage reflection coefficient. Reflection coefficient. This is at the load end and this is at the source end. Okay. Now I will write my IY expression steady state. That means current expression at steady state at any point of transmission line. And this is how I'm going to write it down. I naught plus 1 plus gamma L only, but instead of gamma L, I'm writing minus gamma L. Because what is my minus gamma L? Minus gamma L is my current reflection coefficient. Minus gamma L is my current reflection coefficient. And what is your gamma L? Gamma L is your voltage reflection coefficient. Are you getting this point? Formula will be this only, 1 plus gamma L divided by 1 minus gamma L gamma G. But in place of a voltage reflection coefficient, you are going to put a current reflection coefficient. And what will be your current reflection coefficient? If I say gamma L is my voltage reflection coefficient, then what will be my current reflection coefficient? That would be minus gamma L. That's it. So this is what I am putting. So I naught plus into 1 plus minus gamma L divided by 1 minus gamma L minus gamma G. So IY at steady state, what I am getting? I naught plus into 1 minus gamma L divided by 1 plus gamma L gamma G. So this is what you are getting, but need to make sure what is your gamma L. Here what is your gamma L? Minus gamma L is the current reflection coefficient, but plus gamma L is the voltage reflection coefficient. Okay. A lot of students write this formula and they feel like that. Here 1 plus gamma L divided by 1 minus gamma L gamma G. So will you be able to remember this answer? You will say that, sir, all these are plus plus only. So ahead I will get plus plus, and then you will remember that for GPA upon 1 minus R you get. So that's why in the denominator I will get minus. So in numerator there will be plus, denominator there will be minus. So if you have derivation in mind, then you will be able to write down. Yeah, so you will be able to write down this formula, that is 1 plus gamma L divided by 1 minus gamma L gamma G. Okay, and in the here also why I have put this negative sign. This will be negative sign only, no, not positive sign, because minus minus it will be plus, so 1 minus gamma L gamma G will be there. In case of current, both negative sign would be coming. So if you remember the voltage one, you can write down the current formula very easily. How will you write down the current formula? For current formula, first you will write down the voltage formula only, but you will say that this is the voltage reflection coefficient. If I need to write down the current reflection coefficient, then I need to pick the negative value of that. So negative value you will pick. Is that clear to you? Okay. This formula will be rarely used in your examination, but one question has been asked on this particular formula in GATE 2006. Okay, in GATE 2006, the question was asked on this particular formula. Is that clear to you? And what was your gamma L? Gamma L was voltage reflection coefficient. And what is your gamma G? Gamma G is also voltage reflection coefficient. This is at the load end and this is at the source end. Okay. Now let's see some question. What they are saying, you need to draw the voltage waveform with respect to time. So with respect to time, you need to do the analysis. Source is DC. With respect to time, you need to do the analysis. If you need to do the analysis with respect to time, then how will you do the analysis? V naught plus gamma L V naught plus gamma L gamma G V naught plus gamma L square gamma G V naught plus gamma L square gamma G square V naught plus gamma L cube gamma G square V naught plus. Because with respect to time they are asking. So you need to draw the voltage waveform at y equals to 0, y equals to L by 2 and y equals to L. So where will be y equals to L by 2? This will be y equals to L by 2. So what we are going to do, we are going to make our bounce diagram. So only voltage wave they are asking. Mobile गिर गया भाई. Voltage wave they are asking, but first we need to calculate gamma L and gamma G. What will be my gamma L? What is this voltage reflection coefficient? That would be ZL minus Z naught upon ZL plus Z naught. So that would be 1 by 3. And what about gamma G? Gamma G would be Zg minus Z naught upon Zg plus Z naught. So 25 minus Z naught upon 75. So 25 minus, let's apply this formula, Zg minus Z naught upon Zg plus Z naught. So minus 25 divided by 75, that would be minus 1 by 3. So can I make my bounce diagram now? Certainly I can make my bounce diagram. So in the examination as well, I will make it a bit larger, because in the examination they are not going to ask y equals to L or 0 or L by 2. At one instant they will ask, right? But here we are seeing all. So first V naught plus will be generated, then reflected back. Like till time t equals to infinity, I am certainly not gonna make. I will make for some time instant. Okay. So, so starting with time t equals to 0. This is your source and this is your load. This is my source end. So at the source end, I am having minus 1 by 3, and at load end you are having plus 1 by 3. Okay. So starting here I will get V naught plus, then, or you can write V naught plus here as well, like at from here I will be starting V naught plus, the V naught plus will be reaching here at time t. Then at 2t this will be reaching here, at 3t this will be reaching here, at 4t this will be reaching here, at 5t this will be reaching here, at 6t this will be reaching here. So starting with V naught plus, then what will happen? Gamma L V naught plus, then 1 by 3 V naught plus, then into minus 1 by 3 V naught plus, that would be 1 by 9 V naught plus, but minus sign will be there. Then here what will be coming? Again gamma L will be multiplied, so 1 by 27 V naught plus, but a negative sign would be there. Starting from here V naught plus, then 1 by 3 multiplied, then minus 1 by 3 multiplied, then again 1 by 3 multiplied, then again minus 1 by 3 multiplied, that would be 1 by 81 V naught plus. Then again 1 by 3 multiplied, that would be 1 by 243 V naught plus. Okay, this is your L equals to 0, this is your L equals to L, sorry, Y equals to, really sorry, this is your Y equals to 0, this is your Y equals to L, y equals to 0, this is y equals to L, and the middle one is y equals to L by 2. Is that clear to you? Now we need to find the value of V naught plus. What will be the value of V naught plus? For finding the value of V naught plus, at V naught plus only Z naught it will see. So for finding the value of V naught plus, I will replace my transmission line with Z naught. This is your 300 volt. This is your 25 ohm. ZG is 25 ohm, and Z naught is 50 ohm. So this will be your V naught plus. Your V naught plus will be 50 by 50 plus 25, that is 75 into 300. So what you are getting? 50 by, just a second. Yeah, so this will be 200 volt. Actually, this was a very easy calculation only. Needlessly, I was using calculator. So yeah, V naught plus is 200 volt. So now basically from here 200 volt was going, then 200 volt by 3, then minus 200 volt by 9, then 27 in that manner. Okay, so let's draw the waveform. First we are drawing the waveform at load. What we are doing? We are drawing the amplitude of voltage at load with respect to time. So this is my voltage at load, means y equals to 0 with respect to time. Starting with time t equals to 0. So till time t there will be nothing, right? Till time t there will be 0 voltage. Till time t there will be 0 voltage. Then at time t what will happen? At time t, V naught plus and V naught plus by 3 will come in action. At time t, what I am saying, at time t what will happen? V naught plus and V naught plus by 3 will come in action. So what it would be? 800 by 3 volt. This will come into action at time t. 800 by 3 volt. And till 3t it will remain there, because till t to 3t all these are 200 plus 200 by 3 only. From t to 3t, from t to 3t, 200 plus 200 by 3 will be there. So t to 3t. Let's make it more. Let's make it a bit larger. So t to 3t, from t to 3t, 800 by 3 only will be there. Like at 2t if I ask you, so this will be there 200 plus 200 by 3. So till 3t you will have 200 plus 200 by 3. So till 3t you will have 200 plus 200 by 3, that is 800 by 3. Now add after 3t, at 3t what is the scene? You are having 200 plus 200 by 3 minus 200 by 9 and minus 1 by 27 200 by 9. Basically at 3t what you are having? So at 3t 200 is there, then 200 by 3, then another reflection 200 by 3, then minus 200 by 9 is also there, and then from here 1 by 3 is reflected, then this guy will also be there. So minus 200 by 27. Are you getting this point? So 200 1 plus 1 by 3 minus 1 by 9 minus 1 by 27. So 200, this calculation we need to do. Certainly it will be lesser than 800 by 3 because these two terms are getting subtracted. So shall I do this calculation or you can do it on your own? Let's do it, but using the calculator we will do. So get calculator. 1 by 9 plus 1 by 27 minus 4 by 3 into 200. So this is coming out to be 237.03 approximately. What this is coming out to be? 800 by 3. This is 266.66. This was 266.66. Here I can write down. This is 266.66. Now it has come down to 237.03. Then it will remain there till 5t. 237.03. So it will remain there till 5t. Then at 5t something else will come that we don't know. So that we can analyze if they ask you. 237.03. So at 5t whether it will go upward or downward, that I don't know. So that we can analyze if they ask us. Okay. So at 5t what will be added? This and this will be added. So certainly it will go upward because this is also positive and this is also positive. So voltage will go upward. How much it will go upward, that I don't know, but certainly it will go upward only. So from bounce diagram I can say that it will go upward. By how much amplitude, that I don't know, but certainly it will go upward and will reach here. Then at 70 you can again analyze it will go downward or upward. In that manner we can proceed. Okay, right? So this is the voltage at 0. Now if I draw the voltage at length L, I am drawing now at with respect to time t. So that means at source and I am drawing the voltage now with respect to the time t. So starting with V naught plus, then what we will be getting? 200 plus 200 by 3 minus 200 by 9. So from 0 to 2t, till that time you are having V naught plus only. So from 0 to 2t. So from 0 to 2t you are having V naught plus only. That is 200. Volt. Right. Now at 2t what you are having? At 2t. So voltage at distance L at time 2t, 2t plus you can say. So at that 200 plus 200 by 3 minus 200 by 9. 200 plus 200 by 3 minus 200 by 9. Okay. So 800 by 3 minus 200 by 9. That would be 244.44. 244.44. Basically this we will be having 200 plus 200 by 3 minus 200 by 9. All these three voltage we will be having at time 2t. So just doing the calculation. So 600, 400 by 9. 400 by 9. Yeah, 244.44. So this will remain there till 40. This will remain there till 40. So this is there till 40. That is 244.44 volt. Now after 40 what is the scene? After 40, at 60, at 60 you will have some other amplitude as well. So no, at 40 we are going to see, at 2t we have seen, at 40 what we are going to see is that minus 1 by 27 and plus 1 by 81. So if you write down at voltage at 40, so that would be whatever that is there till 2t, whatever that is there till, basically whatever that is there till this point, plus along with that in this one all these have been already added, now these two will also be added. So what is that? Minus 1 by 27 V naught, minus 1 by 27 V naught plus 1 by 81 V naught plus. Because at 40 whatever you are having, at 40 you are having 200 by 3 minus 200 by 9, then minus 200 by 27 plus 200 by 81, all these you are having. So 1 by 81 minus 1 by 27 minus 0.024 into 200 plus 244.44. So this will be 239.5, roughly around 239.5. So this potential will be 239.5 till 60. Then after 60 you can analyze, in that manner we can proceed. Okay, so till 60, this will be the scene till 60, 239.5 volt. So in that manner you can draw the waveform. One more is left at L by 2. So let's draw at L by 2, but for that I need to add a page. So I need to draw the voltage at L by 2. Charger on gaya. With respect to time t. So till t by 2 there will be no voltage. Why is that so? Because first voltage V naught plus will be coming at t by 2. This time would be t by 2. This time would be 3t by 2. This time would be 5t by 2. This time would be 7t by 2. In that manner we will be going. This time would be 9t by 2. Here where I can write 70 by 2. Here I can write 70 by 2. So for 0 to, at t by 2 you will have 200 volt. At t by 2 you will have 200 volt. And it will be remaining there till 3t by 2. Which is 200 volt. Then at 3t by 2, from 3t by 2 to 5t by 2. At 3t by 2 what is the scene? 200 plus 200 by 3 is there. At 3t by 2 all these two are there, 200 plus 200 by 3. So at 3t by 2 you are having 200 plus 200 by 3, which is equals to 200 plus 200 by 3 is equals to 800 by 3, which is equals to 266.66, right? 266.66. So here at 3t by 2 you are having 266.66. Now at 5t by 2 what you are having? At 5t by 2. So at 5t by 2, at 5t by 2 this much minus 200 by 9. So 266.66 minus 200 by 9 minus 266.66. So that is 244.44. So after that you are having 244.44. 244.44 till what? Till 70 by 2. 244.44. Then after that again at 90 by 2, at 90 by 2 what all you will be having? So no, 3t by 2, 5t by 2 we have at 70 by 2. Now we need to analyze at 70 by 2. So all these 200 plus 200 by 3 minus 200 by 9, 200 plus 200 by 3 minus 200 by 9. So this was 244.44. Now at 70 by 2 this will also be subtracted. So minus 200 by 27. So this will be 237.03. So this will be 237.03. So in that manner we need to proceed. So this is how the voltage waveform. Simply the voltage waveform will be drawn there and they will ask you which of the option is correct. So 237.03 volt. Okay. So in that manner you need to analyze. Just I spent a lot of time on calculation, which I should not have done, but look, every other educator does that, but I am doing it for the first time. So yeah, but this is how you will be doing the calculation. I hope the concept is clear. I hope how we are proceeding in this particular question, that is also clear to you. First gamma L, gamma G, then make the bounce diagram and then just add up the voltages. First our target would be to find V naught plus. What will be your V naught plus? V naught plus will simply come out to be 200 volt. Then you can make that first V naught plus will be going, then gamma L, gamma G, gamma L, gamma G, gamma L square, gamma G, gamma L square, gamma G square. Then in that manner you can do, and then you can draw the waveforms by simply adding up the voltages. Okay. Now pulse excitation. Here what was the input? You can say it was a step input, or you can say it was DC. Basically it was there all the time from t greater than 0. Here we are making, since we are making the graph from t greater than 0, if I am taking the time from t equals to 0, then here it should be written as 300 ut. Okay, the input is 300 ut, that means it is a step input. But here this is a pulse input. Okay, so try analyzing it. I will give you a hint. What is the hint? The hint is you need to break it down into two waveforms. A pulse input can be broken down into two waveforms. How will you break it down? If you have studied signal system or basic mathematics only, if you know, this 15 volt can be written as this waveform plus this waveform. Say yes or no. This is your 15 volt. This is also your 15 volt, but minus here 1 microsecond, and this is your minus 15 volt actually. So if you add both of them, what you are going to get? 0 to 1 microsecond only 15 is there, but after 1 microsecond 15 and minus 15 both are there, so this waveform only you will get. So VG waveform can be broken into two parts like this. So you make the bounce diagram for this guy, you make the bounce diagram for this guy, then you make the diagram for both of them and then just add them up. Are you getting this point? What we need to do, what is determine the voltage response at the midpoint of the transmission line. That means here I need to draw the voltage waveform. Where I need to draw the voltage waveform? Here I need to draw the voltage waveform. This question is from Cheng, okay? So that's why it is standard. So here I need to draw the voltage waveform at this point. Pulse input is there. So pulse input is made up of two inputs. Now first you need to find the transit time. What will be the transit time? Here the insulating material is having a epsilon value of 2.25. Epsilon r is 2.25. So what will be the Vp? What will be the speed? Speed will be c by under root epsilon r. 2.25, that would be 3 into 10 to the power 8 upon 1.5. So that would be 2 into 10 to the power 8 meter per second. So what will be the transient time? Transient time will be length upon speed. That would be 400 upon 2 into 10 to the power 8. So that would be 2 microsecond. So it will take 2 microsecond if this is t equals to 0. If this is t equals to 0, here I am not drawing. If it is t equals to 0, here you will reach at 2 microsecond. But you need to draw right in the middle. So what I am going to do first, I am going to break it into two parts. This VG waveform can be broken into two parts. That once there is a step input, which is this one. This is a very good question. These kind of questions are not asked yet in the examination, but I am pretty hopeful that this is coming anytime. Anytime in future you are going to see these kind of problems. Okay, so this is starting from 0 to, this is time t till infinity it is going. Okay, and this is your voltage 1 I am saying. This is your V1t. And if I draw V2t, then next V2t I need to start from 1 microsecond, because in VG what do I see? In VG I see that at 1 microsecond my voltage is 0. So at 1 microsecond I need to bring minus 15 volt. Right? If this was your 15 volt, so this will be my minus 15 volt, and before that everything will be 0. Okay, this is time t equals to 1 microsecond for time window t. This is equals to minus 15 volt. So with respect to 15 volt you analyze, with respect to minus 15 volt you analyze. Make the bounce diagram for both of them and then you see what is happening. And what is your Vp? Sorry, what is your transient time? transit time is 2 microsecond. Okay, so let's make the bounce diagram now. Source and load end, source and load end. So first V naught plus will be coming into action. So first we need to calculate V naught plus as well. What will be V naught plus? So this is Rg, this is R naught. So first I will be replacing my circuit with, first what I'm gonna do is that I'm gonna replace my circuit with R naught. And gamma L, gamma G also I need to calculate. So now this voltage is changing. Once it is 15 and another time it is minus 15. So as of now I am writing it as a potential V only. So what is my Rg? Rg must be given, series resistance is 25 ohm. And what is your R naught? R naught is 50 ohm. So here your V naught plus, that would come out to be whatever the voltage is there into 50 by 75, whatever the voltage is applied. So 2 by 3 of whatever the voltage is applied. So when 15 is applied, that means when 15 is applied, you will start with, here for this case your V naught plus will be, 15 into 2 by 3, that would be 10. This transit time I will write here. And for this case my V naught plus will be 15 into 2 by 3, that would minus 15 into 2 by 3, that would be minus 10 volt. So here I will be getting started with 10 volt and here I will be getting started with minus 10 volt. Gamma L, gamma G also I need to write. Gamma L, gamma G depends on ZG, Z naught, all these things. So what is my gamma L? ZL minus Z naught. ZL is 0. Line is short circuited. So ZL is 0. So ZL minus Z naught upon ZL plus Z naught. So that is minus 1. And what about gamma G? Gamma G is ZG minus Z naught. What is ZG? 25. So 25 minus 50 upon 25 plus 50. So what that would be? Minus 1 by 3. So here it is minus 1 by 3 and here it is minus 1. Here it is minus 1 by 3. Here it is minus 1. So this is how I will be getting started. Okay. But here I will start from t equals to 0 because 15 is applied at t equals to 0. So initially V naught plus is generated at t equals to 0. Initially V naught plus is generated at t equals to 0. Then at t equals to, how much time it will take? Transit time is 2 microsecond. So at 2 microsecond, gamma L V naught plus will be generated, then gamma L, gamma G, then gamma L square. In that manner we will keep on going. Okay. So starting with 10 volt, then at 2 microsecond, 10 into minus 1, this will be minus 10. Then 10 into minus 1 by 3, that will be 10 by 3. Then minus 10 by 3. Then plus 10 by 9. Just take care of the sign. 10 minus 10. Then again multiply with minus, so plus 10 by 3. Then again multiply with minus, so minus 10 by 3. Then again multiply with minus, so plus 10 by 9. So in that manner we are going. So this is 2 microsecond, this will be 4 microsecond, this will be 6 microsecond, this will be 8 microsecond, and this will be 10 microsecond. But we need to find at the midpoint. So at the midpoint you will have 1 microsecond. This is your 1 microsecond. This time will be your 3 microsecond. This time will be your 5 microsecond. This time will be your 7 microsecond. This time will be your 9 microsecond. So at the midpoint we are finding 1, 3, 5, 7, 9. Now this input is coming into action at t equals to 1 microsecond only. So you will be starting from t equals to 1 microsecond. Okay. So if you start from t equals to 1 microsecond, then again reflection. In that manner reflection will keep on happening. Right. So you will start with minus 10 volt. Then starting with minus 10 volt, then plus 10. 10 plus 10. Then again minus 10 by 3. Then again plus 10 by 3. Then again minus 10 by 9. But this is 1 microsecond, this will be 3 microsecond, this will be 5 microsecond, this will be 7 microsecond, this will be 9 microsecond, because it will take 2 seconds of time. Now what this point will be? This point will be 1 microsecond, this point will be 3 microsecond, this point will be 5 microsecond, and this point will be 7 microsecond. You are understanding every single thing because the concept has been cleared. We have spent a lot of time on building up the concept. Now these things should be clear. Now I will draw the waveform first with respect to this one, then with respect to this one, and then I will add them up. Okay. So this is coming considering plus 15 volt, and where I am drawing V1, I am drawing at the distance L by 2. Okay, with respect to time, considering plus 15 volt, considering plus 15 volt. So till 1 microsecond there is nothing. This is time t. This is time t. Time t in microsecond I am writing. So till 1 microsecond, no wave is coming. First wave is coming at 1 microsecond only. Now I am drawing the diagram with respect to this only. So till 1 microsecond there is nothing. Then at 1 microsecond, which is coming in action, plus 10 volt is coming in action. So at 1 microsecond plus 10 is coming in action, and that will remain there till 3 microsecond. That will remain there till 3 microsecond. So from 1 to 3 microsecond. This is your 3 microsecond. So till 3 microsecond plus 10 volt is coming. No, why I am taking it to 0? That I need to check now. At 3 what is happening? So at 3 plus 10 and minus 10. So you are coming back at 0. Now this 0 will remain there till 5 microsecond. This 0 will remain there till 5 microsecond. Now at 5 microsecond what is happening? Plus 10, minus 10, and then 10 by 3. So at 5 microsecond 10 by 3 is coming into action. And it will remain there till 7 microsecond. So 10 by 3 volt is coming into action. Now what is happening at 7 microsecond? At 7 microsecond, minus 10 by 3 plus 10 by 3 minus 10 plus 10, all will be 0. So at 7 microsecond, it all will be 0, and it 0 will remain there till 9 microsecond. So this is the first waveform. Now another waveform which will be coming because of minus 15. Another waveform will be coming because of minus 15. This waveform is coming because of minus 15. This is voltage V2 at L by 2 with respect to time. So in this one, okay, here I have done the error. This is not 1357. Why this is not 1357? Because waveform is starting at 1 nanosecond, 1 microsecond only, no? So from 1 to 3 microsecond we are reaching at this point. So at midpoint we will reach at 2 microsecond. This will be 4 microsecond, this will be 6 microsecond, and this will be your 8 microsecond. So at 2 microsecond what you are having? At 2 microsecond you are having minus 10. So till 2 microsecond you are not having anything. Because of minus 15, till 2 microsecond you are not having anything. So till 2 microsecond I am not having anything. Then at 2 microsecond, I will develop minus 10, right? At 2 microsecond I will develop minus 10, and it will remain there till 4 microsecond. So it will remain there till 4 microsecond. I will develop minus 10. So till 4 microsecond it will develop. This is your 2 microsecond. So what I will develop? Minus 10 volt. At 4 microsecond what is happening? Minus 10 plus 10, 0. So at 4 microsecond, 0. Now this 0 will be remaining there till 6 microsecond. At 6 microsecond what is happening? At 6 microsecond, plus 10, minus 10, and minus 10 by 3. So at 6 microsecond you are having minus 10 by 3, and it will remain there till 8 microsecond. It will remain there till 8 microsecond. 8 microsecond, what we are getting? Minus 10 by 3. Now at 8 microsecond what is the scene? Plus 10 by 3, minus 10 by 3, plus 10 and minus 10. So at 8 microsecond it is 0, and it will remain there till 10 microsecond. It will remain there till 10 microsecond. 0 volt. Okay. Now I just need to add them up, and I will get my final answer. So how will I add them up? So 0 to 1 second, 0 voltage will be there. 1 to 2 second, 10 voltage will be there. 2 to 3 second, between this is your 2, right? Here also I can mark it up. 1, 2, this will be 3 second, 4 second, 5 second, 6 second, 7 second, 8 second, 9 second. And here if I mark, this will be 4 second, 6, 8. I just need to add both of them. So 0 to 1, 0 plus 0, 0. 1 to 2, 10 plus 0, 10. 2 to 3, 10 minus 10, 0. So look, 0 to 1, 0. Between 1 to 2, 10 plus 0, 10. Between 2 to 3, 2 to 3, 10 plus minus 10. So again 0. Again 0. right? Then 3 to 4, 3 to 4, minus 10 plus 0. So minus 10, 4 to 5, 4 to 5, 0 plus 0. So 4 to 5, 0. Then 5 to 6, 10 by 3, 5 to 6, 0. So 10 by 3 plus 0 is plus 10 by 3 volt. Then 6 to 7, 6 to 7, minus 10 by 3 and plus 10 by 3, that will be 0. Then 7 to 8, 7 to 8 is 0 minus 10 by 3, that means minus 10 by 3. Then 8 to 9, 8 to 9, here 0, here also 0. So 8 to 9, this is 0. So in that manner we are going. Then at 9 to 10, what we are getting, that we don't care. But till 9 microsecond, till 9 microsecond, we have drawn the waveform. Very easily we have drawn it. I hope this is clear to you. So this was our pulse response. So at 200 meter in between here, 200 meter. So at 200 meter, we have drawn the voltage waveform. This is how we will do that transient analysis with respect to the time we are drawing the waveform, considering a lot of reflections from the source end as well and load end as well. So is that transient analysis is clear? All the concept that has been taught, that is clear to you, I guess, right? Pulse excitation we have seen, DC excitation we have seen. First we saw in the initial part of the video, we saw this analysis where we started with the replacing with Z in. But once we need to know V naught plus value, then we need to replace it with Z naught. So this kind of analysis right from the beginning we are seeing, okay? And very amazing question, 2 amazing questions we have solved. So these were not asked in gate examination, but these were asked in the gate examination. So will you be able to solve it? First question, and this is the second one. Okay, only 2 problems, or shall I add more? I can add one more problem. Okay, I will pause the video, take a break. So this question you need to solve, and then you solve this question. I will add one more problem. Okay, one more question I will add here. So that I will add it up. But for now, you solve these 2 problems. Pause the video, solve these 2 problems, and then come back. Okay. Yeah, so let's start the problem. So what is given in this particular question is that source is there, RS is there, and then this transmission line is there, load is there. They have drawn the voltage waveform at Z equals to 0. Usually what do we take? Usually we call it Y equals to 0 and Y equals to L. But they are calling it Z equals to 0 and Z equals to L. They can call anyway, right? But this is our source end. This we got to know that it is our source end. That means it is our Y equals to L. So at Y equals to L, they have drawn the waveform. Okay. Now what they are saying, for what we need to find is that we need to find the value of RL. So RL value we need to find. So they could have avoided giving this 100 volt. Okay. They could have avoided giving this 100 volt. You can find this 100 volt on your own. Because what is this 100 volt? 100 volt is the initial V naught plus. That is your 100 volt. And can you find V naught plus on your own? Yes. For finding V naught plus, what we need to do? We need to replace this transmission line with its Z naught. So if I replace this transmission line with its Z naught, which is equals to 50 ohm, so what I am going to get? Here there is 400. This is 150. And then I will be replacing it with 50 ohm. So 400, 150 and 50. Okay. So now V naught plus. So directly I can see my V naught plus is 400 into 50 divided by 150 plus 50, that is 200. So if you solve it, what you are going to get? 100 volt only. So they are nice. They have given 100 volt already. But even if they did not give it, still you could have told me that it would be 100 volt only. Okay. Now what do you think? What is this 62.5 volt? If I make the bounce diagram, from there I can get to know that what is my 62.5 volt. And bounce diagram I do not need to make again and again, only for one reflection and then another reflection. That's it. Because initially I will be having V naught plus here. Then what will happen? This V naught plus will travel and it will generate gamma L V naught plus, and then this will travel and it will generate gamma L gamma G V naught plus. Right? So here this 62.5 volt, 62.5 volt, this is equals to initially V naught plus, then from load gamma L V naught plus, and then from source gamma L gamma G V naught plus. So this is your 62.5 volt. Okay. So V naught plus value I am already having, that is 100 volt. Now in bracket if I take common, I will get 1 plus gamma L gamma G, and this is equals to 62.5 volt. Okay. Now what about gamma L? Gamma L value I cannot tell because I don't have the value of RL. So gamma L will simply be RL minus R naught. What is my R naught? R naught is 50. So gamma L value will simply be RL minus R naught upon RL plus R naught. But what would be your gamma G value? Gamma G value will be ZG minus Z naught upon ZG plus Z naught. That means 150 minus 50. 150 ZG minus Z naught upon ZG plus Z naught. So that would be 100 by 200. That would be equals to 0.5. Okay. So from here, what do I get? 0.625 is equals to 1 plus gamma L plus 0.5 gamma L. So 1.5 gamma L is equals to negative answer we are getting, right? This is 0.5 only. 1.5 gamma L is equals to minus 0.375. Gamma L value, what you will get? 0.375 divided by 1.5. So where is the gate calculator? I hope you do all the calculation with gate calculator only, because if you are doing with normal calculators, that's of no use. We need to write gate examination, right? So this is your minus 0.25. So this is my minus 0.25. This is the value of gamma L. But this is not we need to find. We need to find RL minus R naught upon RL plus R naught. That means RL minus 50 upon RL plus 50. And that is equals to minus 1 by 4, because minus 2.5. Minus 0.25 is minus 1 by 4 only. So 4 RL minus 200 is equals to minus RL minus 50. So what we are getting? 5 RL is equals to 150. So RL equals to 30 ohm we are getting. So that's the answer. Very simple question. Just you need to write down whatever that you know and you will be getting the answer. Simple calculation is there. So these kind of questions we are not getting wrong in the examination. First we replace with R naught, we get to know our V naught is 100 volt, which is already given. So this was our V naught plus. Then what this would be? V naught plus gamma L V naught, gamma L gamma G. Gamma G we got to know ZG minus Z naught upon ZG plus Z naught, 0.5 I replaced there. Then from there I got to know that it is given as 1.5 gamma L, which would be equals to minus 0.375. From there gamma L value we got to know RL minus R naught upon RL plus R naught. Then simply I did the calculation and from there I got the answer. And the calculation is absolutely correct. There is no doubt about that. Okay. Yeah. So that's the answer. See this question. So this is also a good gate problem and diagram was not given. So you need to make the diagram on your own. A 30 volt battery with zero source resistance. Source resistance is 0, 30 volt battery is there. A 30 volt battery with zero source resistance. Is connected to a coaxial transmission line or coaxial line with characteristic impedance of 50 ohm. So it has a characteristic impedance of 50 ohm. Or Z naught also I can write. Generally we are writing Z naught. So let's write it down as Z naught only. 50 ohm at a t equals to 0 second. This is terminated by a resistive load. It is terminated by a resistive load. This load resistance, and this load is resistive only. So this is your RL. The line length is that it takes 400 microsecond for an electromagnetic wave to travel from source end to load end and vice versa. So what do they mean by this question is that, like, look here I did not understand the language. What they are saying that 400 microsecond takes from go to here to come back here. What do you understand by this line? The line length is such that it takes 400 microsecond for an EM wave to travel from source end to load end and vice versa. That means 400 microsecond to go and 400 microsecond to come back, or 400 microsecond for a complete round. I am not sure, but when we solve this problem, this 400 microsecond will not be used. Look, let me solve this problem. So what will happen is that first V naught plus will go out and then it will come back. What they are asking, what they are saying is that 400 at 400 microsecond, the voltage at the load end is 400 volt. Voltage at the load end is 400 volt at 400 microsecond. So what I am assuming, as per the language, what do I think is that to go there it takes 200 microsecond and to come back it takes another 200 microsecond. Basically what they are saying is that the line length is such that 400 microsecond for EM wave to travel from source end to load end and vice versa. That means source to load and load to source. So language is again not clear. Vice versa is used for 400 microsecond or for load to source. This is not clear actually. right? Like anyone can give any point that for me it is 400 microsecond from load to source, and someone would say that for me it is complete round. But again, when we solve the problem, we will get to know that this statement is not even used. So let's assume it that my transient time is given as 200 microsecond. That means 200 microsecond to go here and then 200 microsecond to come back. What they are asking, at 400 microsecond, the voltage at the load is found to be 40 volt. Voltage at the load at 400 microsecond. So at 400 microsecond, what will be the voltage at the load? What do you think? So you will start from here, then there will be reflections, then another reflection will be there. In that manner, there will be reflection. So what you will be getting started with? First, you will be getting started with V naught plus. Then this will be gamma L V naught plus. Then this will be gamma L gamma G V naught plus. In that manner, we will go, right? Now, this will start at t equals to 0. This will be your 200 microsecond. If I assume that my transient time is 200 microsecond, and this will be your 400 microsecond, right? And this will be your 600 microsecond. So what they are asking, they are saying that at 400 microsecond, voltage at the load is found to be 40 volts. So what will be the voltage at load at 400 microsecond? This will be your 400 microsecond, right? So at 400 microsecond, the voltage at the load is these two guys only. At 400 microsecond, the voltage at the load is these two guys only, because whatever the voltage that you are having at 200 microsecond, the same voltage you will be having at 400 microsecond. Why is that so? Because another 200 it will take here, then another 200 it will take here. So at 600 microsecond, the voltage will be changing. So certainly at 400 microsecond, you are having, what is the voltage at a load? What is the voltage at load at 400 microsecond? What is the voltage? That is V naught plus gamma L V naught plus. Now, if I have taken transient time to be 400 microsecond only, that means this time will be 400 microsecond. Then this time would be 800. This time would be 48. This time would be 1200. So at 400 microsecond, if you ask me what is the voltage at the load, then what I will say? These two only. Because at 400 microsecond, V naught plus has come and gamma L V naught has been reflected. So again, I would say the same thing. At 400 microsecond, these two voltage are only there. So whether you take the complete round for 400 microsecond or only one round, only for one reflection you take 400 microsecond. Any point you take, your answer is coming V naught plus gamma L V naught plus only. Are you getting this point? Like I solved this question considering both of the cases because the language is not clear. If I consider that 200 microsecond is taken to go from here to here, then also it is fine. If I assume that 400 microsecond is taken to go from here to here, then also I am getting the same answer, because at 400 microsecond, here the voltage is V naught plus gamma L V naught plus. Certainly, while framing the question, while framing this question or while writing down this line, they must have thought of something. They must have thought whether they thought of 200 microsecond or they thought of 400 microsecond. But luckily, the question got framed in a manner that even if you take 400 microsecond or 200 microsecond, still you get the same answer. So in the examination, whenever these kind of condition occur, you should not think that, sir, okay, I will not be able to solve this problem. No, do not think that. Just go with one of the approach. Certainly you will find something. Okay, but this is an easy question. We should not drop these kind of question in the examination. So we will go with one approach. Certainly we will get something in the problem. Okay, so these kind of questions should not be dropped just because of the language. So never drop any question just because of the language. The language is not clear. If you drop it, then you will regret it. Okay, so language was not clear, but certainly answer is going to be same. So what we got to know is that that at 400 microsecond we are having this much voltage, and this is equals to 40 volt. 40 volt. Now what is your V naught plus? What is your V naught plus? So how will I find that? For finding V naught plus, what do? We replace our input, we replace our transmission line with Z naught. So what I am gonna do, I will replace my transmission line with Z naught. So battery is 30 volt, and I will replace my transmission line with Z naught impedance. Why I am replacing with Z naught? Because for V naught plus only it will see Z naught only, right? So what will be my V naught plus impedance? What will be my V naught plus voltage? This will be my V naught plus voltage. So since there is no ZG, so complete voltage will be coming here. So V naught plus will be equals to 30 volt only. Okay, so value of V naught plus is 30 volt. Are you getting this point? initially just as the switch is closed, just as here the switch is closed, here I should have made a switch. Better, I should have made a switch. So just as the switch is closed, then V naught plus is generated. So if V naught plus is generated, that will see Z naught only, and V naught plus value is 30 volt. So from here, if I solve, 30 volt into 1 plus gamma L is equals to 40. So gamma L is coming out to be 1 by 3. So you are getting gamma L value as 1 by 3. If gamma L is 1 by 3, then can you let me know the value of load resistance you need to find? So load resistance will be ZL minus Z naught upon ZL plus Z naught, and value is 1 by 3. Z naught value is 50 ohm. Z naught value is 50 ohm. So 50 I can put here. So ZL should come out to be 100, right? From here, if you solve, ZL should come out to be 100 ohm. How did I write 100 very quickly? What did I do? I just picked randomly that ZL could be 100. So 100 minus 50, 50 divided by 150. That would be 1 by 3 only. So you can solve it, or you can directly see that ZL will be 100 ohm. So first question has been answered, that what is the value of load resistance? That is 100 ohm. Steady state current they are asking. Okay. For steady state current, what I need to do? If I go by my first method, what is my first method? If steady state thing they are asking, I will replace it with Z in. This is what I do. I replace it with Z in. Can I replace it with Z in? I know the load resistance value, that is 100 ohm. But do I know the length? No. I cannot replace it with Z in. So here I am going to apply that formula. Which formula? 1 plus gamma L upon 1 minus gamma L. That formula I am going to apply. Are you getting this point? Here I cannot replace the circuit with Z in. So no matter, I need to take a lot of reflection in action. And if I am taking a lot of reflection in action, then which formula I get? So steady state voltage, steady state current they are asking through load resistance. Actually what I would have done is that first I would have found Z in, then I would have found VSIS there, then I would have found VSIS. With the help of VSIS, I would have found VL and IL. But that I cannot do now because I don't have the length. I don't have the length. If length was mentioned, then I could have found Z in, and with respect to that, I could have solved it. How I would have solved it? First, I would have found VSIS, then I would apply those formula. Which formula? Vy equals to VL cos hyperbolic gamma y plus IL Z naught sin hyperbolic gamma y. That formula I would have applied and got the answer. This in the beginning of the lecture we solved in that manner. But here I cannot do it, right? Because length is not mentioned. If length is not mentioned, then which formula I am going to apply? So what I need to do? I at y equals to 0. Basically at steady state you need to find the current. What that current would be? I naught plus. So I remember the formula for voltage, that was V naught plus, everything was added, but in the denominator 1 minus R would be coming. So that would be gamma L gamma G. Now if I am writing down for current, so what that would be? 1 minus gamma L divided by 1 minus gamma L gamma G. Why again minus? Because this will be minus gamma L, this will be minus gamma G. Minus minus will be plus. So this was the formula for current. You don't need to mug up the formula for current, you just remember the formula for voltage. And how will you remember plus minus sign? Because A upon 1 minus R would be coming. So here minus and upper side there will be plus. So this is how you can remember it. So gamma L value. What is the value of gamma L? Gamma L is the voltage reflection coefficient. So what is the value of gamma L? That is 1 by 3. And what will be the value of gamma G? That would be, this is voltage reflection coefficient at the source end. So that would be Zg minus Z naught upon Zg plus Z naught. Or what is the value of Zg? Zg is 0. So 0 minus Z naught upon 0 plus Z naught. So that would be minus 1. So what is the value of gamma G? That is minus 1. And do you know I naught plus? Do you know I naught plus? This is my V naught plus. So what will be my I naught plus? If I know the value of V naught plus, what will be I naught plus? I naught plus will simply be V naught plus by Z naught, right? Because Z naught value I know, Z naught is V naught plus divided by I naught plus. So I naught plus will be V naught plus divided by Z naught. What is my V naught plus? 30. What is my Z naught? 50. So I naught plus is 3 by 5 ampere. So here 3 by 5 ampere I am getting I naught plus. So 3 by 5 into 1 minus gamma L. What is the value of gamma L? 1 by 3 divided by 1 minus what is the value of gamma L? 1 by 3. And what is the value of gamma G? That is minus 1. Okay. So this is 4 by 3. This is 2 by 3. So 2 by 5 divided by 4 by 3. So 2 by 5 will be 0.4. divided by 4 by 3. 4 by 3. So that is coming out to be 0.3. Okay. So answer is coming out to be 0.3 ampere. So your current at load steady state is approximately 0.3 ampere. Is that clear to you? We just applied the formula and put the value. I naught plus we got to know that it is 3 by 5 because 30 by 50. Then I just put it here 1 minus 1 by 3, 1 minus 1 by 3 into minus 1. Then 0.3 ampere we are getting. So this was a gate problem only. Two questions were there, ZL and current. Okay, very easy. Let's solve one more gate problem. So this question you try it on your own. The magnitude of the voltage at the open circuit end you need to find. That means at the load you need to find the magnitude of voltage. VL you need to find. Here what is your IL? Can you directly tell me? Here, what is your IL? Here my IL is 0 ampere because open circuit load is there. The length is lambda by 4. What I need to find? VL I need to find. So what is my first way? My first way would be by replacing the complete one to Z in. This is how I find. I will consider only V naught plus and V naught minus. So if that method I am considering, that means I am replacing it with Z in. Why I am replacing it with why I am replacing it with Z in? Because at steady state, I will say that all the incident reflection, everything will be there. So at steady state, all incident reflection, everything is there. So I will replace the circuit with Z in. What will be my Z in? Can you let me know? What is the length? Length is lambda by 4. Length is lambda by 4. And for lambda by 4 length, what is Z in? That is Z naught square divided by ZL. And what is the value of ZL? ZL is infinity. So what will be your Z in? Short circuit. So your Z in is short circuit. And what is your source? Source is 10 volt and 50 ohm resistance. And load, and this Z in is short circuited. So across Z in, what do you get? Vs and Is. Vs and Is. So what is the value of Vs you are getting? 0 volt. Why 0 volt? Because I replaced my transmission line with Z in and Z in is complete shorted. If it is shorted, that means Vs is 0 volt. And what is my Is? Is is 10 by 50, that is 1 by 5 ampere. So this is my Is. What I need to find? I need to find VL. What else I know? IL is 0. Okay. So Vy equation I already know since this is a lossless transmission line. So VL cos beta L plus IL Z naught. Something IL Z naught would come, but that is 0 only. IL is 0 only, no? IL Z naught sin beta L. J IL Z naught sin beta L. But that is 0 only. And here what do you get? Iy is equals to IL, that is 0, cos beta L plus J VL by Z naught sin beta L. And what is the value of beta L here? Beta L, that is 2 pi by lambda into lambda by 4. Beta L is pi by 2. So now if you write down, Vy we were writing, no? Vy. We were writing Vy here. This is my Vy. But what do I know? I know the expression at y equals to L. What is your Vs? Vs is your voltage at y equals to L. And what is your Is? Is is your current at y equals to L. If you apply these formulas, in these formula, what is the y? Y is the distance from load. So Vs is your VL and Is is your IL. This thing you already know. Distance from the load. And what is the value of L? L is equals to lambda by 4. Where L is equals to lambda by 4. So as per this, what we can write? So my voltage at y equals to L, that is given as Vs, and that is equals to VL cos beta L. What is the value of beta L? That is pi by 2. Beta L is pi by 2. Are you sure? Cos beta L. Yeah, it is pi by 2 only. Okay. And this is equals to Vs. Oh, Vs is already given. So if you solve it, what is cos pi by 2? 0 only. Cos pi by 2 is 0 and Vs is also 0. So certainly you are getting 0. So from here you are not getting anything conclusive. Let's write down I expression. I at y equals to L. What that would be? J into VL that I need to find divided by Z naught. What is the value of Z naught? 300. Sin beta L. What is the value of beta L? Beta L is pi by 2. And this is equals to your Is. Right? This is equals to Is. And that is equals to 1 by 5 ampere. So from here you can get something conclusive, right? So from here what I am getting, JVL by 300, sin pi by 2 is 1 only, 1 by 5. So VL is equals to minus J 60 volt. Okay, and if I take the magnitude, this will be equals to 60 volt. So this is the answer. This is how we need to solve it. So here I am not going to apply that formula ZL minus Z0 upon ZG plus Z0. This is my first approach. My first approach will always be that I replace my circuit if they are asking me steady state voltage at open circuit line and or at load or at a source, whatever they are asking. So first I will be replacing my line with my Zin. Once I replace it, I will get the value of VSIS. If I need to find out the load, then I need to manipulate the equations. So first I put the value of IL and VL, all these values I put here. Then equations I was getting. Now what do I know? I know the value at L distance from load. That means I know the value of VYL. Vy equals to L, and I know the value of Iy equals to L. So from Vy equals to L, I was not getting anything conclusive because that was equals to 0 only. But from Iy equals to L, I was getting something conclusive. What was that? JVL by 300 sin pi by 2, that was equals to 1 by 5 ampere. So JVL is getting, so JVL was equals to 60 volts. So VL is minus J60 volts. So mode of VL is 60 volt. So this is what they asked. They asked the magnitude. The magnitude of voltage at the open circuit line is 60 volt. That's it. So this is the end of this video. This was a very typical concept and a lot of guys was confused in this particular concept. Now all the confusion would have been cleared and all kind of questions also we have solved. In the next video we are going to see the power transfer on transmission line. That is also a confusing topic. Okay, power transfer is also a confusing topic. So that also we are going to see. So in the next lecture we are going to start. So this was a 2.5 hour video, a long video it was, but I hope you enjoyed it. Every single concept I have cleared and every single misconception, along with that every single doubt also have been addressed in this particular video. So let me know how did you find this video, it was helpful or not. Okay, thank you very much.